Okay, I think we'll get started then. So, welcome to FOSS4G. So, welcome to Edinburgh as well, Scotland. For those of you who it's their first time up here, hope you make the most of it. We've got some good weather, we've got a few evening events and you get out and about. But no, it's absolutely fantastic to see that so many people have come along to this event. It's been a sellout, which is amazing. But it isn't surprising because, you know, FOSS4G is really growing in all the different sectors across the UK, and the community of contributors is in really good health. So it's great to see you all here, but we're not surprised that there's so many of you. So first of all, thank you to our sponsors. It's been amazing. The support has been incredible. And thank you so much for coming on so early in the process. We started the process of putting this conference together 18 months ago, and it was only because the sponsors got on board so soon that we were able to get great venues and sort out all the different things that we've got in store for you. So thank you very much to our Gold Plus, our Gold sponsors as well, and the big middle there of the Silver sponsors, and even the Bronze sponsors. All really important, really great that so many people got on board and supported the conference. Little bit of housekeeping. The toilets you have passed on the staircase on the way down, so they're on the second floor, in between here and where the catering is on the third floor. And there's some on the other side of the building for those who are doing workshops as well, on the same floor as the workshop rooms. We have no planned fire alarm tests, so if you do hear a fire alarm, please make your way calmly to the nearest fire exit that are all clearly marked. And just to note that we're also running this conference under the OSGeo Code of Conduct. So if you want to look that up, have a look on the OSGeo website, their Code of Conduct. But generally, good behavior is required. So, about the conference, please talk to people. This is how all the good stuff happens at these conferences. FOSS4G is well used, but there's still much to learn for everyone, connections to be made. So get out there, make sure that you talk to us. I know it's not easy for some people, so if you do see someone lurking around your conversation, try and bring them in, get them included, get them enthused about FOSS4G. Ask questions as well. Don't hold back. There's some great speakers we've got here, the keynotes and the other presentations. But if there's anything else that you want to know, other people are probably wanting to know it too. So be brave, put your hand up and ask some questions. Also, spread the word. So if you're on Twitter or any other social media, the hashtag we're using is just FOSS4GUK. Just keep it nice and simple. So I hope to see some of your comments there. We are live streaming this event, so I am live on YouTube right now. All the talks will be live streamed, not the workshops, just the talks. So check out the YouTube channel. If you just search for FOSS4GUK on YouTube, you'll be able to find it quite easily. Yeah, so the travel grant program, we're supporting that by raffling off some of these amazing Great Britain's Biggest Islands posters, kindly donated by Alistair Ray. So we've got 9 of those to give away. I've got a book of raffle tickets in my back pocket, so they're £1 each. All the money that we make will be going to the travel grant program. So yes, just to keep things moving now, I'd like to ask Joe Cook, who's the chair of OSGeo, OSGeo UK, to come up and say a few words to open the conference.
Figure out how to work this laptop, of course.
Oh, what's happened?
That's it, my phone. Yeah. Cool. So, hi everybody. It's absolutely fabulous to see everybody here. It's great to see lots of old faces. I mean, not actually old, but people I haven't seen for a long time. And it's great to see a whole. So I've moved my lanyard around because I'm, as well as being here from Aston, one of the sponsors, I'm the chair and the founder of OSGeo UK. So hands up if nobody had ever really heard of OSGeo kind of before. Don't be shy. A few people, yeah, that's fine. I'll see you later. So OSGeo is the open source geospatial foundation, and really without OSGeo, a lot of the projects that you know and love wouldn't really be around, although in some cases they've kind of outgrown OSGeo itself. But I'll talk a little bit about OSGeo in a second, but and I also need to talk about OSGeo UK, who are the local chapter, because OSGeo itself is a global organisation, and it works by having local chapters in particular geographic territories, or in some cases it has language chapters. So we're OSGeo UK. So as I said, OSGeo is a global foundation, and its mission, in short, is to support open source software, but also the people that use it. Now, it supports the software by providing an incubation program so that projects can ensure due diligence, can sort out their licensing. Back in the day, it used to provide infrastructure for hosting. Of course, that's not really needed anymore. But things like mailing lists and, you know, obviously events like this. So I tried to get some numbers for how many people there are, how many members of OSGeo there are worldwide, and it was a real struggle. And as is usual with these things, I got loads of debate about it on the mailing list about how you actually define a member. But basically, if you look at the OSGeo mailing lists for all the products and, you know, the committees, there's over 30,000 people signed up. And this little map here indicates where they come from. So you see, it is generally a global organisation, obviously with some areas that are not really represented particularly. But also we're talking about global corporations as well as individuals. And the one thing that OSGeo is very proud of is these conferences being the meeting of the tribes. So this is where you get to meet people who are interested in other products, in other software, but also, you know, as Tom said, just other interested folk. This is from the Nottingham event in 2013, this slide. So as I said, its role is to promote sustainable, properly licensed software, QGIS, PostGIS, the big ones, but also smaller packages like PG routing and Loader, and to provide advice on the best packages for you to use. If you're interested in more about OSGeo UK, we've got an AGM at 1 p.m. today in the turret room. So come along, it's nothing formal, so just come along and find out more. So to end, a couple of quotes to sum up what I kind of think about OSGeo and FOSS4GUK. The first is from Anita Roddick, who said, if you think you're too small to have an impact, try going to bed with a mosquito in the room. You guys are all mosquitoes. By using the software, by taking the time to come to this event, you have an enormous impact. But also, try and remember that behind every piece of software and every conference is a real person. So your thanks and your contributions, even if it's just typos and documentation, they might just be the thing that keeps people going, inspires them to keep going, keep doing their software. So thanks ever so to everybody that's the sponsors, the organising committee, and to all of you for coming along to the event. And just one final quote, this time from Abraham Lincoln in 1988. Be excellent to each other. And enjoy the event. There we go.
Thank you very much, Joe. So, just to keep things moving along, I'd like to invite to the stage Shona Nicol, who is the head of Geospatial for the Scottish Government. I'll just get your presentation up. Go back to the beginning.
Hopefully don't look at my slides before I've had a chance to actually talk to you about them.
Great. And just a quick note for other speakers to keep close to the microphones. Because we're going live on the internet, it just helps with the audio.
Thank you very much, and thanks very much for inviting me along today to speak to everyone. I thought I would just maybe start off by giving everyone here a little bit of information about who I am and where I work and what the team that I head up do within Scottish Government as well. So my name is Shona Nicholl. I head up the Geographic Information Science and Analysis team within Scottish Government, which I'll come to why we're called that shortly. We sit within the Directorate for Digital within Scottish Government, and within that directorate, we sit within the data division. So we have a Chief Data Officer within Scottish Government, and I report into him. But I guess just to start off with, I thought I would maybe give people a little bit of an idea about what the team within Scottish Government do. So we are a geospatial team, and we do lots of different things, ranging from setting some of the geospatial data policy for Scottish public sector. So we look at things like how do we make sure that Scotland's voice at the UK level is listened to. So we engage quite a lot with the UK government and the UK Geospatial Commission, which I'll talk about a little bit later on in my talk. I've also been doing a little bit of work around drafting up a Scottish geospatial strategy, which again, I'll talk about in a few minutes. But we also have to make sure that the public sector in Scotland meet a lot of the statutory requirements for things like Inspire. So that's one side, is looking at that policy perspective. I guess the other areas that we get involved in are that central procurement of public sector spatial data for the public sector in Scotland. So I'm, for my sins, responsible for the One Scotland Mapping Agreement, which is an agreement we have with Ordnance Survey to make sure everyone in the Scottish public sector gets access to OS data. We also have a number of other data collaborations around aerial photography, about Earth observation and remote sense data, all of which my team are responsible for managing to make sure that we're all using the same core data within the public sector in Scotland. And then I guess the final area that the team are involved in is around casework. So we're responsible for managing and keeping up to date and maintaining a whole range of what we call key spatial data sets, ones that are of national importance. And I'll come on to some of those later on in my talk as well. And then I guess the final last little area is that we also get involved in lots of policy-led analysis. So the whole role of data within Scottish Government is to provide that evidence base, and we're one of the areas that people come to within Scottish Government to ask for that, what kind of evidence they can provide us with while when they're making some policy decisions. So that's really just the context of where and what the team within Scottish Government do. There's not many of us, there's only 6 of us. So we've got quite a lot of work that we've got to do, and we depend on the rest of the public sector in Scotland actually helping us achieve a lot of these goals. But just to put in a little bit more of a wider context, I don't just sit within the digital directorate within Scottish Government. Scottish Government itself has a whole range of different purposes and strategies and legal commitments that we have around data and innovation. So for example, Scottish Government's purpose is to create a more successful country, with opportunities for all of Scotland to flourish through increased well-being, sustained and inclusive economic growth. We have a whole range of ways of measuring that purpose. So we have 11 national outcomes that look to see how well Scottish Government is achieving that purpose. We have a whole range of different strategies, some at Scotland's level, some at the UK level, so ranging from things like the Digital Strategy for Scotland, which is trying to create this open and outward-looking digital nation. We have Scotland's Economic Strategy, which is looking at a more productive, cohesive and fairer Scotland. And then we have at the UK level, we have things like the UK Industrial Strategy, looking at putting the UK at the forefront of industries of the future. But aside from that, we also have our own plan for the coming year. So Scottish Government recently published a Programme for Government in 2019. And that really sets out the actions that we're going to take over the next year. And for this specific Programme for Government, it was looking at how we can end Scotland's contribution to global climate change. So these are all very high-level strategies, and we need to think about how we, within my team, feed into those. If we look at the Programme for Government, we see a few different areas where spatial data gets picked up. So the first one is around this idea of data-driven innovation. So how do we take some of these new sources of environmental data to help us meet some of that action that we set out under Programme for Government. Looking at the space sector as well, Scotland already very strong in the space sector, and one of the ambitions is for us to become the first country in Europe to provide an end-to-end solution for small satellite manufacture, launch, and innovation in satellite data analysis. So we've got, there's lots of stuff within that Programme for Government that talks about geospatial, and we've really got to sort of try and do as much as we can to help government meet that, the actions that are set out underneath it. But there is another little bit of context that we shouldn't really forget as well. At the UK level, we have something called the UK Geospatial Commission. Many of you will know about this already. It was created 2017. I guess some of the work around the setup of the Geospatial Commission was the benefit that geospatial could bring to GDP through better exploiting and making more efficient use of geospatial data. Obviously, seeing figures like that makes a lot of people in the public sector think a lot more and look a lot more closely at geospatial data. The Commission also had a certain amount of money that they were able to use to deliver some of their objectives over the coming years as well. At this moment in time, the Commission is in place, the independent commissioners are there. We have a Scottish Observer that sits on that group, and we've been working with them on a number of projects. For example, the Geovation Hub that Register Scotland leading on, and you'll see a table upstairs about that if you want to know a little bit more. The Commission are looking at publishing a UK strategy on geospatial by the end of this year or beginning of next year. And again, we just want to make sure that Scotland's requirements are well fed into that. So we want to make sure that whatever priorities we have are reflected in that wider UK strategy. So I guess for many years I resisted this idea of doing a geospatial strategy for Scotland because we've got so many strategies already that we hardly need another one. But I guess when you have something like the Geospatial Commission coming along, we have to think about what our priorities are in Scotland and think about, are there going to be places where we value different aspects of a strategy? So the UK might be looking in one direction and we might value something slightly different. So over the last kind of year, really, I've been going around speaking to people within the community in Scotland to help pull together a draft. I'm calling it a strategy. It could be a high-level delivery plan as well. I haven't quite set on what I'm going to call everything yet. But really, this slide here just sets out the vision that we have, which is using geospatial data to connect people, places, and things, driving innovation, improving public services, and unlocking economic value for Scotland. And I guess there are 4 different work streams that we're looking at. One around data, one about skills, one about innovation, and one about collaboration. And I'm just going to go into each of these 4 areas in a little bit more detail. And then I'll have all the dry stuff out of the way, and we can start talking about what we're actually doing with geospatial data within Scottish Government. So as I said before, this is probably less a hard tomb strategy and more a set of drivers and actions that we need to take in order to meet that objective. So you'll see from this slide here, so this is the work stream on data, and it's really looking at how we improve the quality and interoperability of that geospatial data that we hold within Scotland in order for us to reach the potential and meet some of these aims that are set out under Programme for Government. So we've got a whole range of different areas that we're going to look at. Some of that's around discoverability. A lot of the events that we ran within Scotland, discoverability and being able to find data came up time and time again. We want to improve the way that people can reuse some of that geospatial data. So some of this is around the licensing that's out there. It's making the metadata better so that people can actually understand how that data was created. It's also about improving the way that we collect and store and manage a lot of the geospatial data in Scotland as well. So moving from having these individual data stores to something maybe that's on the cloud and is much more accessible for people. The second work stream is really around skills. And again, this came up quite a lot in the events that we held throughout Scotland. People thinking about what's the capacity and capability that we have around geospatial data? What's the talent pool that we have in Scotland for geospatial? And on one hand, some of this is about skilling up people that are already in the workplace. So, I mean, this is really important to me because obviously I have a team of GIS analysts and I want to make sure that they are they have a career in the long term, and thinking about all the things that are happening in this wider world around open source software, around data science, and how do GIS people fit within that bigger world. And I guess the other area is looking at how you improve the capacity for the future talent pool as well. So how do we go about making sure that more people come in to the geospatial world and get skilled up in it, and make sure that my team, for example, have got in the future will constantly be able to bring new staff in. So there's a whole range of areas that we're working on for skills as well. The final two areas, as you can see, are maybe a little bit less worked through than some of the others. As I say, this is still a work in progress and not totally finished. So we have a work stream on innovation, and that's really looking at how do we improve the environment that we have in Scotland to encourage innovation, and how do we foster that culture. How do we work with some of the existing centres of, how do we develop and support centres of excellence within the geospatial world as well? We have some centre of excellence around Earth observation at the UK level that work really well, and some of this is just about thinking about those models and how can we use them in other areas. The final work stream then is around partnership and collaboration. Now, we've worked really hard in the public sector in Scotland to try and make sure that we do collaborate on lots of stuff, that we work in partnership with each other, and we'll talk a little bit more about that shortly. But how do we do that collaboration between academia and industry as well? And when we're talking about collaboration at the public sector level, we've got to think about the funding and the cost benefits for all of that as well. So that was a very quick run through of the strategy. If people would like to talk to me about it, I've got plenty of time later on today. I'm quite happy to talk about this in a little bit more detail. If you've got thoughts about it, please come and talk to me as well. But I guess I'm just going to run through really quickly now some of the areas, some of the things that we're already doing around geospatial data within the Scottish public sector. So the first thing I want to talk about really is just go into a little bit more detail about what data we've got and what we've done in that wider world around data. So if you don't know already, and I really hope you do, we have a discovery portal in Scotland, spatialdata.gov.scot. It's actually run and managed by Aston, who are here today as well. So again, if you want to get the details about that particular portal, you can speak to them as well. But really, this is a place to make sure that I guess it's basically the discovery component for public sector geospatial data and services. And we have lots and lots of data and links to services on there. We do ask that when people put their metadata on there that they continue to maintain that over time, and they look at improving their data and their metadata as well. The site itself has a whole range of different metadata templates. The data gets harvested up to data.gov. There is an API available as well that people can use. And actually, I think we can even harvest in other organizations' metadata as long as they're in specific formats. So have a check out and see what you think of it. I mean, a lot of this sits within this bigger context of Inspire as well. So I had mentioned some of the legislative things that we have to make sure the public sector in Scotland achieves. Inspire is one of them. It underpins a whole range of different portals within Scotland, Scotland's Environment Web, Scotland's, the Improvement Service Spatial Hub as well. I always just like to tell people, unfortunately, it's been my job for the last 6 months to make sure that Inspire will work after EU exit, so you can all say thanks to me for that one later, that's fine. So it will continue, whether we're in Europe or not. There is a new metadata standard coming your way, so Gemini 2.3, and I'm sure you're all going to hear more about that as the year progresses. Inspire itself talks about harmonising high-value data sets. Now, I've always taken a bit of a pragmatic approach to Inspire. I don't necessarily need you to go away and read the specifications in a lot of detail, but we do have to harmonise data, and we've got some examples of where this works in Scotland. We have the Improvement Service Spatial Hub that's collecting data from 32 local authorities, harmonising that and making national data sets. Now, that might not be to the Inspire specifications, but it's still really important for any of the work that we're doing in Scotland. But really, just to go back to the spatialdata.gov.scot site, I just wanted to pull up a couple of examples of data that you'll find on there to talk a little bit about what I do or my team do within Scottish Government, and maybe some of the other teams within the public sector in Scotland. So you probably, I mean, I hate having acronyms, but I couldn't really fit Scottish Index of Multiple Deprivation. It's quite a long title, so you got the acronym on this one, I'm afraid. But basically, this is a big bit of work that we carry out in my team. We've actually just completed the latest version of SIMD. It's probably going to get published later on this year. So we're involved in the accessibility analysis. So we look at the drive times and the public transport journey times to key services. So that's the geographic access domain is the one that we're involved in. We also do a little bit of geolocating for the crime domain as well. Now, the SIMD is updated every few years, and every year we have to start a whole year in advance to think about what data do we want to use, what timings, make sure that the road network and the public transport times and the speeds and the ferry routes that we manage all come from within the time frame, tidy that data up and create this big data set. Obviously, this data is fundamental to lots of different things within Scottish Government. A lot of the work around deprivation really does inform lots of different policies. So you're looking at things, I mean, there's some stuff up here about what are the links between mental health and deprivation, and then deprivation and education as well. So it's one of the big core key data sets that we create within the Scottish Government. And I guess the other one, again, that we're starting to work on right now is around the creation of a statistical geography called data zones. So data zones are the key statistical unit for Scottish public sector. It's the geography that we publish all our stats on. And again, there is another portal I haven't mentioned up here, but it is, I'm going to forget the name of it, statistics.gov.scot, where you'll be able to get all the stats based at data zone level from the Scottish public sector. Right now, we're involved in redrawing the new data zone boundaries as part of the bigger work around the census. So we work really closely with the organisation that does the census in Scotland to make sure that the output areas that they use to collect that data fit and make sense at the local level as well. So we'll be consulting with local authorities to make sure those boundaries work for them, and then we'll look at the changes between the previous boundaries and the new ones as well. And I guess the final data set that I just want to mention that you can find on spatialdata.gov.scot is one from SNH, and there are lots of people here from SNH today as well, so if you've got any questions, they're at the front. But I guess the habitat map of Scotland and the sea map as well that you've got defines the habitats on land and surrounding sea areas. So I guess what I wanted to say here about the habitat map is it's kind of another example of why we need to do a lot more work around the harmonising of data that's held within the Scottish public sector. SNH had to take data from multiple sources in the public sector, standardise that, bring them all together into one place, and use a standardised classification against all of these. And that is also available as open data. Now that took SNH quite a lot of work to standardise the whole range of different layers that were used to create the habitat map. And again, it's an area that we're working on to see if we can improve the way that the Scottish public sector actually do classify their land use, their land cover data as well. So I mentioned one portal which was about discovery. The second portal that I want to talk about is one that again we use, which is the Scottish Remote Sensing Portal. So this is a portal that was created in partnership with JNCC, and really it was to encourage the public sector to share any of the remote sensing data that they had purchased, that they had collected themselves. The portal is kind of new. It's only been up maybe for a year or so now, and we're constantly trying to develop and think about making improvements to it. In the short term, right now, the portal only has LiDAR data, and obviously in Scotland we don't have LiDAR data for the whole of Scotland. We've only got it for very specific areas. But that data is there for anyone to download and use. In the long run, we really want to see this as a place where a lot of remote sensing data that has been collected or procured by the public sector is available for people to use for free. And I guess one of the places that you can look, we do actually have a remote sensing index, which is on spatialdata.gov.scot, and that tells you the range of remote sensing data that's held by the public sector in Scotland. Now, I mentioned that we don't have a mass amount of LiDAR data in Scotland, and like the rest of the UK, so down south in England, you have the Environment Agency that's collecting LiDAR constantly for them. We haven't quite got that same resource here. But we have been working quite a lot over the last year or two to start thinking about how do we procure LiDAR for Scotland. So we know, for example, and I mentioned it earlier, that under the Programme for Government, that there's lots of talk there about flood protection measures, that continue to invest in that area, and then investing in the new sources of environmental data that will tackle climate change. So we've got a hook, I guess, on which to hang a lot of this work around LiDAR. But you can see from the slides that there's lots of other organisations within the public sector that need LiDAR data for lots and lots of different purposes. So we all need it. We all need to think about how we're going to procure that and how we can share that data with each other. So, you know, we've been doing quite a lot of work on this collaboration on LiDAR. And I guess the first thing to say is that we actually have been able to buy some more LiDAR. So in November, later on this year, you should be able to see some more LiDAR for Scotland. So it's what we're calling phase 3, obviously follow on from the first 2 phases of LiDAR. Now this is data from 2015 and 16. It'll be available under an open government license. We also have some data, LiDAR data for the Outer Hebrides as well, that SEPA are in the process of having flown. Again, this will be an open government license. And they really wanted to collect a lot of information around the coast. So they have been looking at collecting that data 2 hours either side of low tide. For both of these bits of LiDAR, we consulted quite widely within the public sector to make sure that we were getting the right areas, and that the resolution and DTMs, DSMs, and LAS files were all that that the public sector were going to need to be able to do their work. But as I say, all of that data will go out as open government data as well. So I mentioned a little bit there about some of the open data sets that we've got. I guess the final area I want to talk a little bit about is just around another set of open data, which is Earth observation data. So obviously there are a whole new data sources that have started to come online around remote sensing, and Copernicus is one of the big ones. And I guess what we've been trying to do is think about what kind of questions can we start to ask now that we've got Earth observation data that's covering Scotland every 3 to 5 days. Can we use some of this data to think about the way that we deliver the public services within Scotland? So we've been trying to think about, over the last few years, what are the ways that we could use Copernicus. And I guess we've been doing a series of cross-agency Earth observation projects. So we've been working with DEFRA down south, SNH, SEPA, Forestry Commission, to try and figure out what are the different ways that we could use EO data within the Scottish public sector. So we did a number of different kind of case studies, I guess. So we looked at, could we use this to look at diffuse pollution? Could we use this to monitor peatland condition? Could we assess wind damage in forests? Could we map trees outside of Scottish woodlands? Can we look at a crop map for Scotland? And can we look at coastal change as well? Can we look at monitoring coastal change? So we've run a few of these, and I'll talk about some of them in a moment as well. And there's more actually on the slide here as well. So things around wildfires and emergency response as well. But obviously in Scotland, we do have the big issue of cloud cover. So unfortunately, as you can imagine, there's some of us in this room, well, maybe they're not in the room right now, but Forestry Commission, having to explain to a minister that you haven't been able to do that a little bit of analysis because you didn't have enough cloud-free days in Scotland that year. So we do have to think about what other data we can get from Copernicus that is useful in Scotland. So things like like radar data. So looking at that to see if we can identify wind damage and crop maps and things like that using radar data rather than an actual imagery. So I just wanted to give a couple of examples, I guess, of where we've been using some of this Earth observation. And again, this example is coming from S&H, so if you want more details, I'm sure they'll be very happy to help. But the first one was really around wildfires. So wildfires can cause significant damage to biodiversity, agriculture, forestry, and it can threaten infrastructures and properties and things like this as well. Now, because of the whole climate change, there is likely to be more wildfire incidents, and this, S&H have got to start looking at being able to assess the extent of any wildfires and the severity of these wildfires as well. So to help assess the damage that wildfires are doing, S&H did a little bit of work looking at, so they triggered the Copernicus Emergency Mapping Service back in 2018 to look to see if they could collect data to help them look at the wildfires in Sutherland. So Sentinel-2 obviously unfortunately couldn't collect cloud-free imagery, so we had to task a few satellites to actually look at that area. So that was the first use of it. It worked pretty well. I guess in spring 2019 there were further incidences of wildfires across Scotland. And I think the example that S&H always give is the one to do with the Isle of Bute, which makes quite an interesting case study, I think, for maybe two specific reasons. The first is that they were able to calibrate the severity recorded on the ground with the information that they'd gathered from the imagery before and after the fire. So they were able to do, to do that, to look to see if they could compare what was on the ground and what they discovered from imagery. But secondly, I guess Bute had wildfires over a number of different years, and from that they can start to think about, well, what is the impact of frequent fires on the likelihood of it recurring? How does that impact habitat recovery and various things like this? But S&H are not the only ones that are interested in fires or wildfires. We have lots of areas within the public sector thinking about muir burns, looking at heather moorland that is burnt, often to provide fresh growth for grouse as well. So we know that there's a few other areas within the public sector that are interested in this kind of thing. And again, we're going to be investigating that a little bit further. I guess the final example that I wanted to give was, again, to do with environmental aspects. So this is looking at dynamic coast. So coastlines are very dynamic environments. They're very vulnerable to climate change. And this work was really looking at whether we could use Sentinel-2 to identify an intertidal zone. So, and I guess that's to be able to identify the extent of the foreshore and compare that to other bits of data looking at shorelines. So, I mean, there are lots and lots of examples of where we're using Earth observation within the public sector. I chair the Remote Sensing Working Group for the public sector. We are always very happy to have people come and talk to us about bits of work that their organisations or their companies are involved in. You're going to hear a little bit more later on today, so there is another part of Scottish Government that's going to be talking about crop map as well. And just to say that we are still investigating that what other ways can we use some of this Earth observation data. So we've been working with the Scottish Centre for Excellence in Satellite Applications to look at some of this stuff around wildfires, coastal monitoring and tree felling and various things like that. And I think that's the end of my slides. So again, I just really wanted to say thank you to everyone for letting me to come and talk to everyone here. And I would probably just reiterate what was said at the beginning, which is come and talk to people. If you've got any questions about anything I've said, please come and talk to me about it. Yeah, enjoy the rest of the day. So thank you very much.
Right, thank you very much, Shona. Thank you, Joe, for those talks. Right, it's break time. So if you would like to make your way back up to the concourse. Sorry. if any of our speakers are around for the next session or any of the sessions, then please find someone in a purple t-shirt to put their talks onto the laptops or get everything set up too. But we'll see you after the break.
Our first, I suppose, submitted talk session of FOSS4G Edinburgh, and while this is called the Getting Technical session, I like to think of this as the Lancaster session. From Lancaster University, along with myself and the speaker after Barry, we'll kick off with Barry Rowlingson from Lancaster University's Medical School.
Okay, has the clock started? You're on the clock, okay. So this is, in a way, a bit of a history talk of my entire career in geographic information systems, which started back in 1990 with the Northwest Regional Research Lab. Now, this was a Research Council-sponsored set of laboratories around the country, which were to innovate in GIS. And in particular, I was at the Northwest Regional Research Lab in Lancaster, where we worked in health information systems and spatial epidemiology, in GIS and emergency planning, and in methods for spatial inference. And the other labs were doing various other interesting things as well. And we one of the things the RRLs were doing was we were tasked to develop new technologies, particularly interfaces to commercial packages. Because open source wasn't invented back then, we had to work with commercial packages. We had some statistics skills in Lancaster with professors in statistics. So we thought we'd look at how we can interface statistics with geographic information systems. In particular, spatial statistics, the statistical analysis of spatial data. And so we thought, how do we do that? Well, what's the current state of affairs? What does GIS, statistics, and data visualization look like back in around 1990? There were sort of three systems. You were either doing GIS, you were either doing graphics, or you were either doing statistics. And these things weren't integrated. So how do we integrate these things? Let's see what we've got. Statistics packages look like this. They were basically streams of text. Your data was read in from a file. You told it what instructions you wanted to do, what model you were fitting on that data, and it spewed out the results in another file or in a table like this. And you went, okay, that kind of looks interesting. What am I going to do with that data? You saved it in a file. You then fired up your graphics program. You loaded the data into the graphics program, decided which was your x-axis, which was your y-axis, what curve you wanted to fit through it, so forth. Click a few more buttons, and out came a graphic plot like that. Okay, that's interesting. I want to make a map now, so I fire up my GIS, and this is what ArcInfo looked like in 1990. It was command line driven. There were no menus to speak of. And you would run your ARC commands and eventually get a wonderful, fantastic looking map, which you would then submit to the Esri Map Atlas for that year and win great prizes. Okay, what we wanted to do was, the first thing I was thinking is, let's see if I can do simple data presentation, simple graphics of the data in my ArcInfo system. For example, I might want to plot a histogram of distance from school to road, or any of those sort of basic statistics that we kind of want to do now. And I kind of hacked on the Unigraph system and ArcInfo version 4, whatever it was, to try and get plots from ArcInfo into Unigraph. It was pretty clunky and it crashed. This was all working on Unix systems at the C level, and my programming wasn't that brilliant at the time. And yeah, trying to get the graphics into ArcInfo was a bit of a dead end, so I gave up on that. Because what was happening at the time is that statistical packages were getting much more graphical. This is spooling forward a few more years. This screenshot is from the mid-90s of S+, which was then becoming a prevalent statistical analysis system in universities. And you can see that it's got much nicer graphics than the text thing I showed you a couple of slides ago. You could now plot things that looked kind of 3D, fit lines, draw things, there's menus and buttons. In fact, the old sort of command line interface is now relegated to that box down there. So it's still there. And I thought, well, statistics is now getting the graphics. If I can get statistics into the GIS, then I get the graphics for free. And that kind of led me to work on a sort of loose coupling system of ArcInfo to S+, where I created some new ArcInfo commands, which would do things like transfer the data to S+, and then there was a command which would let me run an arbitrary S+ function without leaving the ArcInfo prompt, and then I would pull the data from S+ back into ARC, where I could then draw it as a raster, or change the data, or make graphics or whatever. That actually worked, and I've still got some of the code that did this from the 90s. It doesn't work because I don't have an ARC info license anymore, which I hope many of you don't. And this worked by transferring the instructions and some of the data through a Unix pipe, a named pipe. It looks like a file on the disk, but things can write and read to it. And that sort of worked, except every now and then the S+ process, which was acting as a server, listening for commands from ArcInfo, would get out of synchronization and everything would stop, and it was horribly clunky, so I gave up on that. So that's two things I've given up on. I give up on a lot of things. But meanwhile, GIS was coming into statistics, and the packages like S+ were having the capability now to draw nice maps and to draw polygons, and I wrote some code to do some statistical point pattern analysis and to do things like a simple point in polygon test, so we could restrict our cases to a particular region that we might be interested in. So statistics was getting GIS, and GIS and statistics had the plots and graphs. So we got all those three things from that trinity all in one statistics package now. And the code we released in '93, very basic statistics thing, was called Splanks. It's a package for S+. And we sold that at a cost of £60 because open source still wasn't invented yet in 1993. But then one day, one bright day, the sun came up and open source was invented. And in that time, the S language, which underlies that S+ package, was re-implemented into the R package, which is an implementation of the S language. And so we've now got an open source version of S that we can use. Fantastic. And because it's open source, anyone can hack on it, and people have integrated that with all the open source geospatial libraries that we know and love and that are featured in this conference. So there are interfaces to GDAL and GEOS and Proj and OpenStreetMap, and you can get data from geonames, you can get the all the satellite data and vector data are all packages for that. It's very easy to get spatial data into S+ now. And R's cartography got better as well. So there are now packages that will produce pretty maps like this and interface them with leaflet, so you can do them on the web. They're all very great. And meanwhile, while R's cartography is improving, QGIS's cartography is improving as well. So here's a couple of maps I just dredged up from Liam Mason, who's here for the conference at some point, just to show some QGIS's cartography. The problem with R's graphics is the interactivity. R's plots are pretty much static. You can throw things out onto leaflet and make web maps, but again, the interaction goes. And one of the things I love about QGIS is the speed of the mapping. This is a plot of Ritalin prescription in England, coloured by how much per child in that doctor's surgery. And you can see on the right, if I plot that in R, I would see a plot like that plot on the right, and I wouldn't be able to interact with it. Whereas with QGIS, I can split this in half, I can zoom in, and I can see that in Merseyside, if you cross over from Liverpool onto the Wirral, the spending on Ritalin per child goes up by a factor of 5. And we don't understand this. We published this a few years ago, and no one's really kind of explained that why. And there are other differences in Ritalin prescribing and prescribing in general that are very weird, and being able to interact with them with QGIS was a way I discovered some of these features. So I thought, how can we get QGIS's cartography into R? My first thought was that R can call Python. Python lets you, well, QGIS let you write applications in Python. So I thought I could write some R code that would import QGIS as a Python module, and I'd have a QGIS window that I could then send data to. And that sort of worked, except that QGIS runs on this event loop. So in order to make QGIS interactive, you've got to break out from R and have a QGIS event thing running, and R is now not running, and the interactivity is not quite as neat as I wanted. So I gave up on that again. Then I discovered that the Qt toolkit that QGIS uses has the capability of listening on a network socket. And that works in a fully integrated manner to all the other sources of events that QGIS is getting. So every time you click on the QGIS canvas, that's an event that goes to the QGIS core, to the event loop. And you can have something listening on the network that then sends events to that event loop, and it's all done asynchronously. So my vision was to have an R client which would send requests through the network to QGIS that was listening. So this is the basis of the QGIS remote control. But it doesn't have to be just R, because if you choose a nice protocol, then R can send requests to QGIS, Python can send requests to QGIS, anything that constructs an HTTP request can then act as a remote control to QGIS. I thought this is quite a neat idea. I won't give up on this just yet. Yeah, okay, that just explains the asynchronous nature of how anything can talk to the QGIS core, and it's all asynchronous. So I wrote a little proof of concept thing that worked. I had the client and the server working. I asked on the QGIS mailing list, does this sound useful? And people went, yeah, that's quite neat. Don't think there's anything like it at the moment. And then I thought, well, where do I find the time to do this? Because I'm a full-time academic with teaching commitments and lots of research projects. And it was coming around for Google Summer of Code. And if you don't know about Google Summer of Code, every North Hemisphere summer, Google will fund a whole load of open source projects. You find a mentoring organization, which in my case was OSGeo, and you apply, and Google will fund a student. And in this case, we got Kevin Stadler, and I had Julia Waggerman as a co-mentor, and the project was funded. It's great. We had Kevin working for many weeks on this. And what he produced, and he did most of the work, was a QGIS plugin called Network API, which listens on port 8090, and an R package called QGIS Remote, which talks that way. And we thought of a security model and how we're going to convert the data backwards and forwards and so forth. And here it is running. So let me see. This is a R session up here with, which has attached the QGIS API package and started a new project. And you can see over here that the network API is alive with that little tick box. And the map that you see there has actually been transferred from R through those commands, and it's been styled in R as well. And it's all done without leaving, without not having an interactive R session and not having an interactive, or keeping an interactive QGIS session. Both sessions are interactive at the same time. And that works really well. Okay, so we managed to get all this functionality in the package. We could create raster and vector layers from R spatial data into QGIS. We can add tiles. We can get geometries and selection back from QGIS. So you could do an interactive selection on QGIS and then get back into R what you've selected. And you can change the styling. You can actually remote control zoom the canvas around. You can even run processing algorithms. And you can get the current QGIS image back. And that's a neat little trick in that you can just put a URL in your browser and it will pull that QGIS image onto your browser window, which is quite neat. Okay, live demo. No, sorry. Yeah, we started this just as QGIS 3 was not quite ready, and QGIS 2.7, whatever it was, the last, or 2.9, 10, I don't know, the old QGIS 2 series was coming to an end. And so we wrote with Python 2.7 because QGIS 3 wasn't quite stable, and when QGIS 3 was finally released, it didn't work. I have since thought, well, maybe this old Land Rover, which I photographed in Mull, there's a campsite in Mull which has got about half a dozen old Land Rovers sitting outside it, and I wanted to take some home because my Land Rover was sitting there in the campsite, feeling sad that all these wrecked Land Rovers were there. But yeah, I'm working on a refurbishment of the project for QGIS 3. I'm also working on a refurbishment of my Land Rover. It's currently in bits, and it's going to be shiny and lovely and wonderful when it's finished. And I will drive back to Mull and have another holiday and rescue one of those old Land Rovers back. But that's another story. I've started a QGIS 3 branch on the GitLab repository, and I want to get better data synchronization between the two systems. And I want to run it over HTTPS for a bit more security, because at the moment it runs over HTTP as a simple password protection, which isn't kind of secure enough for some people. And if this all works, that will be great, and we'll have finally have the best integration between statistics analysis, statistical graphics, and GIS from the last 30 years that I've been doing this kind of integration, as well as a load of other stuff. I've been doing some more important things than just hacking around with software for the last 30 years. So I would like to thank Kevin, who really wrote 99% of the code. I'm upping my percentage here for the project. Julia, who co-supervised with lots of interesting ideas. Her angle was to look at how we could use this kind of interface from Jupyter notebooks. So you could have a Python Jupyter notebook, which then called this API to get QGIS cartography into your Jupyter notebook. I'd like to thank Google and Google Summer of Code for funding Kevin and for funding the t-shirt. This is the only thing I got from the project, apart from the satisfaction. Google do send you a t-shirt to every mentor. I'd like to thank every QGIS developer ever. I've met quite a few of them. They're all great people. And I'd like to thank the medical school where I work for giving me the time to work on this project. And if anyone wants to be a doctor, applications will be starting very soon, I think. If anyone's interested in contributing or has comments, ideas for this project, you can say now. It's all kind of ticking over in your heads. Or come and find me in today or tomorrow and let me know what you think. Thank you very much. I'll probably take 1 minute. I've got a couple of minutes. Yeah.
We've got a couple of minutes, 4 minutes for questions. There is a mic at the back, so please wave a hand and we'll kick off. Fantastic. Maybe I'll be so lucky tomorrow. I was going to say stolen, that's not true because you haven't seen it yet. Some of the ideas from the talk I'll be giving tomorrow, and I think it's really interesting, this idea of sort of how, and Shona touched on it as well, how data science and GIS are meeting and where we can learn from each other. And it's, I suppose as John and I were both at Lancaster in the early noughties, it's remarkable that kind of none of this really filtered through to the environmental sciences department, but there were other things going on there. Did you work at all much with people, I suppose, like Paul Young or Vladek Tick?
I know them, and I know people in our department who are working with Paul Young, but I think environmental sciences back then were very interested in running sort of huge models of data on the high-end computing processing, and they weren't really looking at the more small-scale GIS. And I think GIS kind of came down a bit around about 2000 at the university as a whole. But we're picking it up now, and we'll see where it goes. We have a data science institute as well, which we're part of as well. It should be influencing that. Okay.
Any more questions? Otherwise, Barry will be about and possibly change into one of these T-shirts. Do you want to just set it up on the lectern, or maybe you can just stick it on top of that one? Our next speaker is from the British Geological Survey, and I've known John for many years, so it really gives me great pleasure to introduce John Stevenson.
Okay, thank you very much. Yes, my name is John Stevenson. I'm a senior software developer at the British Geological Survey, and my talk today is about open source spatial ETL using Python and Apache Airflow. So one of the projects we've been working on recently in the BGS is something called UK Geos, and this is all about monitoring this beneath the surface of the Earth. We've got a network with lots of sensors, and they're all down boreholes all around in Glasgow already, and we're putting in more Cardiff and other places. And we want to make that data available to the public so that they can see what's going on. And most of the data that's within BGS gets stored in a central Oracle database as the main store. But for this project, we want to move it out into Postgres databases that can then feed web apps, and they'll serve the data to the public. And so what this presentation is about how we've done that, and we've come to do it with an ETL process. ETL is extract, transform, and load, to get the data from Postgres to get the data from Oracle to Postgres, sorry. So that's the general plan, but first things first. There's a freaking massive elephant in the room. Anyone who does any work with spatial ETL will have heard of FME. So FME is a proprietary software tool that's used for migrating data, and it's used in many places, government and academia, places like that. BGS got licenses, so the obvious question would be, well, why didn't you just use FME? I've used FME before quite a lot. I know where it's strong, I know where it's less strong, and those things have kind of given me an idea of what, in my mind, would be my ideal ETL tool, and that's kind of what this talk is about, and I'll show you what I mean now. So to do this, I'll compare FME, which a lot of people will know, with Python and how the ecosystem is. So the first thing you want is something that's easy to get started, and FME does very well at this. It's got a nice graphic interface, one database, another database, draw a line between them, and the data start flow. It's very easy. Python doesn't do so well here. As far as programming languages go, it's pretty easy to use, but still, if you want to do databases, you need to know what driver you're using, how to do connection strings. You might be worried about cursors and transactions and memory management, stuff like that. So it's not really that easy to get started. Next, you want to have a graphic interface so you can control your jobs. And FME, again, is good at this. You get FME server, it gives you a web page. You can see how your pipelines are getting on. You can start and stop jobs. You can look at the logs. Everything's very nice. Python, again, normally, if people have written their code in Python, it's probably going to be a command line script. That's not much use for the product manager to come and have a look at, see how things are getting on. Moving on, I want my ETL to be open source. So this is where Python wins out, open source language. People often think the benefit of open source is financial, but here, even if I had infinite money, I would still want my project to be open source. The reasons for that, first one would be philosophical. So this is a project we're working on. We're taking data for science to give it to the public, and we want everything to be transparent, and we want it to be reproducible. And that means that we want anyone to look at our code, to reproduce our pipelines, and see the results that we get. If you're using proprietary software for science, then the tools are black boxes, and your code is not transparent in the same way. Second reason is more practical. My kind of day-to-day world now is full of continuous integration and Docker containers and infrastructure as code. And in this world, you basically want to define everything so you can destroy servers and recreate them again. If you start using proprietary tools, then that brings in licenses and proprietary binary blobs, and all of these things are just a headache that I would rather do without. I want my ETL to be version controllable. If you've got multiple people working on your tool, then you want to make sure that they can each work on their own different bits, and when you bring them together again, you can see what's changed. Python, it's software, there's lots of tools for doing that. It goes into Git very nicely. Technically, FME workbench files are XML, so they're plain text, you should be able to diff them. But in practice, you can take a workbench, open it up, move a transformer, save it again, and when you diff the two files, there's 300 lines have changed. So in practice, FME files aren't actually version controllable, and that is a major hurdle for me. Also, automated tests. Again, Python, if you write your code as a series of little functions, you can do it a little bit at a time. You can put a test around each of the functions, and you don't need to worry about the whole thing. FME, the workbenches are like one big flow. So you get data in, and you get data out, and you can't really see what's happening in between. Maybe you could write a script, I've done it before, where you write a script that sets up a data, runs the workbench, and sees what comes out. But if you're at the stage where you're doing that, then you might as well just do the whole thing in Python anyway. So that's where I am with kind of ETL tools. And from the graph here at the top, if you are a database admin or something, then you can see that FME is right up there, whereas the software developer side is leaning towards the stuff down at the bottom. And the questions you have is like, oh, well, if only we could make Python a bit better. And that's where this comes in. So this is ETL Helper. ETL Helper is a Python library to simplify data transfer between databases. So this is a tool that we've written in BGS internally, and we've released it just now in time for this conference so that any of you can use it. It began as a script that Joe Walsh wrote so that we could automate the installation of the Oracle drivers, and it's grown from there, and now it's got tools for moving the data. So the co-authors are here, Joe's here, and Colin's here, and please come and speak to us and ask us about us. And The main bit of the next bit of this talk is just going to be a quick run through of how that works so that you can try it for yourselves. There's going to be a bit of code on these slides, but the kind of take-home point I want to be is that there's not much code. And so even if you are a DBA who's only done a little bit of Python, then it should be stuff that you'll be able to write for yourself. Now, the first thing that ETL Helper does is it gives you a nice way to store your database parameters. So we've got this DB params class, and you can see here you define the host, the database, the username, everything else. That's pretty straightforward. The reason we do this is because there are lots of different drivers and everything that Python uses. So the Oracle driver is different to the Postgres one, is different to SQL Server. By using this interface here, we can abstract that stuff away so you don't need to worry about it. Because all that you really want to do is you want to get some rows. And if you're using ETL Helper, this is how you get the rows. You take your database definitions, you write a SQL statement to get the SQL, and then you set up a connection with a password here, and then you do get rows, and you get your rows out just like that. A couple of things to say about this. The Aura password there isn't actually the Oracle password. It is the name of an environment variable where the password is stored. So the reason we've done that is so that people aren't writing the passwords into their code and storing it in their version control. So that's an environment variable where the password is stored. And the data that comes out, you get a named tuple out, a list of named tuples. So you can get all your native Python objects in here, and you can access them either by their index, or you can do row.value, row.id, and you can get the data like that. You can also do parameterized queries, so you could do select from source where ID equals and pass values into that. And you can do a row factory. You can get the data as a dictionary if you want, which makes it handy to convert to JSON if you're going to be sending it over the web. Talking about ETL though, we want to copy rows. Well, copying rows isn't much harder. You've got two databases and you've got two SQL statements, one for selecting the data and one for inserting it into the next one. Set all those up, and then you run copy rows and you can transfer the data across. One thing that you can do here is you can do some manipulation of your data as well. So for example, in the insert SQL, you could call an upper function to make your thing uppercase, or you could call a timestamp function. You could add an extra column to put a migrated date column into the target data. So you can do some stuff there. But to be an ETL, the T in ETL is transform, so we have capabilities for that as well. To do a transform, then you're able to apply a transform function. So if you look at the copy rows command at the bottom, you can see we've got this extra line, transform equals my transform. Now the transform can be any function you want that takes a chunk, which is just an iterable, like a list full of rows, and that returns another chunk, which is a list full of rows. And if you look at the example here, this code will get a random number, call it external value, and if that number is less than 5, it will just drop that row off. So you can use your transform as a filter, and the external value you could call out to another web service or query another database or do whatever you want to get that in. So you just put whatever you want in the transform function. And as far as software testing goes, that's a function that has an input and an output and no other dependencies, so it's really easy. You can test that and you can prove that it works. I build this as a spatial ETL, but the thing to remember here is actually spatial isn't special. It's just another database command. And if you've got a spatial database, then you don't need to worry about drivers for all the spatial transformations because they're in the database anyway, and you can just do it in the SQL. So if you're taking data out of Oracle, it has a function that will take the binary Oracle blob and turn it into well-known text. And then when you put it into Postgres, you just use the equivalent Postgres function to turn the text back into Postgres blob. And you can do it all in there. You can also do more transformations in the SQL. So you can apply a transform function when the data goes in there. You could also do intersections and buffers and other things like that. So basically, the spatial stuff, in 90% of the cases, you can do it in the SQL anyway. And again, if you've got a DBA writing this, then they're all over that. They can do that really easily. So what we're not doing here is converting between different GIS formats or loading shapefiles or anything. But if you wanted to do that, you should be using OGR to OGR anyway. And if you did want to do some more complicated geometry transformations, you can use Shapely, which is a Python library for doing that kind of thing. So when you put all those things together, then your ETL script boils down to just something as simple as this. Do your imports, write your queries, set up your connections, and run the commands. You'll notice in this one here, I've got an extra delete SQL statement. What's useful in your ETLs is before you do the insertion, if you just do a delete and delete the rows that you're going to insert, then that means that you don't have a clash, you don't get duplicate ID errors, and it makes your script idempotent, which means you can run it over and over again, and you always get the same result back out. So you'll see here, the main takeaway from this is that the actual transfer is in a function, and then, as typical Python scripts, you have this line at the bottom that says, if I'm running this, call the function. And that's it. You could just put that in a cron job, and it would run away, and you would have your ETL. But really, what I said was that we want to have a GUI. And that's where Airflow comes in. So the strapline for Airflow is when workflows are defined as code, they become more maintainable, versionable, testable, and collaborative. That was music to my ears when I first read that. That is exactly the kind of point that I was trying to make here. So Airflow was written by Airbnb, and then they released it as an open source project. And they use it, it's not an ETL in terms of transferring data, it's more of a task management workflow engine type project. So they use it every day. They've got all their transactions in a relational database, and they run it to process them, aggregate them, and put the data into a different database so that the data scientists can then work on it. So it's for doing things like that, repeating your jobs. And it's got things like it can watch databases or files, and it can kick off a job when they change, or it can run a job again if it fails, and things like that. So it's very nice. And first of all, our best thing is it has a GUI. So it gives you a nice web graphical user interface. It runs on your server. You can log in. You can see jobs that are running. You can start them. You can stop them. You can read the logs, all the things that we wanted to do. The diagram we've got here is showing my sensor data workflow. So we've got observatories and measures. Those are two quite small tables. Observatories is a spatial one because it's got the location of the sites. And then we've got the readings. And the readings are time series data, measurements from the sensors. We've got millions of those in one big table. And we have our Airflow DAG, which is a directed acyclic graph, which is the name of the job that moves all the stuff along. So how do you write a DAG? Well, there's more code in this bit. This code's a little bit more technical than the ETL stuff, but again, there's not much of it, so you should be able to cope. A DAG, then, you just define your job. You give it a name. You say how often you want it to run. You say what the oldest data you're interested in is. So I want data from 2018 in February. And you say catch up equals true. So that's saying if the server starts up and you give it this job and I haven't got the data from back then, go all the way back and bring all the data through for me. And that's it. That's how you define your workflow. And what the DAG does is it calls a series of operators, and the operators are the jobs. So in this case, we're using a Python operator. And to do the Python operator, what we've done is we've imported our copy observatory script. And all we do is set the callable to that main method, like we showed in the other one. So copy observatories.copy observatories, and that runs a script. And that's your task. And you can do things like define other tasks. So latest only operator means that if you are running lots of jobs, it will only run once. And there's also things like a bash operator. So if you've got an OGR job that's loading shapefiles, you can run that on the schedule as well. And you can see how they relate by saying what's upstream and what's downstream and stuff. You can also pass arguments to your operators. So to move the readings data, this was the big time series, then the function there actually has a start date and an end date, which it takes as parameters. And if you want to pass those in, you can take your function and wrap it in another one. So what I've done here is the copy with args one takes the start date and the end date from these keyword arguments that Airflow provides, and then it passes them to the function. And you make that your job. You say provide context so it's got that data, and that means that that job will run for each of the days of data you're interested in. The beauty of this means that if you've got a full load, no problem. So if you've got previously, if you had an ETL job and it worked fine for a day's worth of data, and then you do a query to tell it to move 6 months or a year, what often happens is the database fills up all its memory, it all grinds to a halt, and it takes forever to go through. what Airflow does is it has a series of workers that take jobs from a queue. So if you want to move a year's worth of data, Airflow will calculate a job for every day. It'll put the jobs in a queue. You can have as many workers as you want, and they'll just take the jobs off, move them one at a time, and they'll give you a little result as it goes through. So that means that you can scale it right up, and you can move full data sets with exactly the same code that you used to move a small one. And so that's it. So that was the state that I thought we were in with the ideal ETL tool, but now, easy to get started. Well, if you use ETL helper, then it's not hard to get started. You can use that. And if you want a job control GUI, you can use Apache, and then you've got that. So now the situation looks like this. And for me, it would basically be Python every time. And that's it. Thank you very much. So just one thing, ETL helper is now available on PyPy. That's the pip command. Please install it, try it out, give us feedback. I'd be really pleased to hear how it works. Thank you.
Thanks, John. We've got time for one or two short questions.
How hard is it to install Airflow?
It's just pip install Airflow. A pip install Apache Airflow.
Dependencies, it just kind of work. It's pip, you know, you can pip install stuff in Magic, and then you can pip install stuff and be in a pit of misery.
Yeah, yeah. Well, I've never had trouble with it, but and I would hope it'd be on the easier side because it's not got to compile any complicated geometry stuff. So I think it's probably straightforward. And also, you can run Airflow. It comes with a series of different components, so the scheduler is separate to the web interface, and you can do that with Docker containers if you're into that as well. Yeah. So to run, well, so yes, if you just want to run it, so that is the kind of philosophy we're aiming for here is those Python scripts are all standalone. So you can just run them on your machine, anything that's got Python whenever you want, and then you copy them to Airflow and you can make Airflow run them for you instead. Yeah. Okay.
Okay, thanks very much, John. Our next speaker, all the way from Berlin, is Mila Friedrich.
Thanks. Yeah, I will. All right. Hi, everyone. My name is Mila Frerichs. I'm from Berlin, Germany, as he said. I'm happy to be here in Scotland. It was a good opportunity for me to come to Scotland and see our beautiful country. So I'm really happy to be here, and I hope you enjoy my talk. I know it's a mouthful. That's why I always skip the first part, and I will just show you what it's all about. So I help civic advocacy groups inform the public with geospatial data visualizations to increase transparency and accountability. So that's my day job, but I love working with notebooks, and we are here to talk all about notebooks. Not these kind of notebooks, but actually these three kinds of notebooks. So we're talking about Jupyter notebooks, R Markdown notebooks, and a new one that is observable. And you might think, which of one of these is the best? And as always, that depends. That really depends on your use case. And I use all of them, so I encourage you to check out everyone. I want to show you 3 ways I use these notebooks to create geospatial analysis and creating geospatial data visualizations. And at the end, I show you some tools how you can make your usage of notebooks even better. For an agricultural client, I use Jupyter notebooks for 2 things. To understand an algorithm that someone that left the company created and no one knew how it worked, which is kind of a bad thing, but it happens, right? So it was written in Python, and that's why I thought it's the best way to use Jupyter notebooks to try to understand the code and visualize the way the code works. What the code actually does is it turns Sentinel images into fertilization application parameters for farmers, as you can see on this. So we're taking Sentinel data and turning it into this, which is in-field variable fertilization applications. And so my task was to update that code into a more advanced version of it. But as I said, nobody really know what the code is actually doing. So on the higher level, they knew what it does, right? So you put in Sentinel data and you get something out. But the actual implementation of it was kind of a black hole. And so what I did is take the code line by line, put it into Jupyter Notebooks, and try to understand what's going on, what all the transformation that was happening were doing. And Jupyter Notebooks was a great way to really visualize the way all of the small steps of going from a satellite image to some kind of output really helps to do that. And one way for using Jupyter Notebooks is to understand code. And what I did then is not only have a way for myself to understand the code, but to actually show what the code is doing to the others, so that when I leave, they will know what it's doing, right? So that's why I created updated the Jupyter Notebook to have more explanations in it. I created a presentation out of it, and now more people at the company know what the code is doing, and they can update it now. The second way I used notebooks was to show the improvements that we made with the algorithm. And I worked with an agronomist side by side, and I used Jupyter Notebooks to help him understand what's going on, and to have a way for him to see how the algorithm is improving the output that we are looking for, and for him to have a way to give me feedback. So he run the notebook on his own computer. I helped him set it up. So even if he's an uncoder, he has no idea what code is. But I was able to set up a Jupyter Notebook on his machine, and he has a way to changing the parameters of that notebook to see the output. And so he knows way more about agriculture than I do, right? Because I'm a coder, he's the agronomist. So I helped him understand a way to improve the algorithm. So he knew all the steps that the algorithm was doing, and he found a way to communicate with me where maybe flaws are, where maybe some errors were going, and we used the notebooks as a discussion point to improve the algorithm even further. The next project I was involved in is a school zoning app developed by a data scientist, a friend of mine. And he's a good programmer, but he used R and choose R to build a prototype quickly and do some exploratory analysis before he even built the app that actually resulted in that. So he used R Markdown to do the exploratory analysis and build a data pipeline to go from the data input that he had, which used open data. He collected all the data with R Markdown notebooks and then did the analysis and the transformation of that geospatial data to have this output there. And then on top of that, he built an R Shiny app, which was an easy way to use that R Markdown file and the notebook that he created to have an output that everybody can see and play around with. And so this code is running in production. So he built an app out of it, and the R Markdown file is still the way to explain how the data pipeline works, and also running in production on an R server to create these outputs. And there's a huge ecosystem around R to help improve our notebooks. And there's a great talk that I encourage you to check out from Kartik Ram at RStudioConf, where he explained more how you can use R to create these R Markdown files and use R Markdown notebooks. There is a lot of critique about Jupyter Notebooks that I'm aware of, and there was a huge fight on Twitter like 2 years ago or so where a lot of data scientists and a lot of people chime in and said Jupyter notebooks are not really a good way to do analysis. And I agree with a few of these remarks, but there are ways we could help ourselves to do better. And one way is using observable notebooks. So they took on the challenge to make Jupyter notebooks better. And they invented a whole new flavor of JavaScript. So this is now running on JavaScript to create notebooks. And it includes all the things that people say, or I would agree, that Jupyter notebooks lack, at least built in. And so here's a list of the features that they included. So we have version control built into it. We can fork notebooks and create our own version of it, and even make like kind of a pull request to the change to the notebook that we forked on. It has a real reactive environment. So every time you change a cell, all these cells that depend on that cell will update. So you don't need to run it yourself, which is like a kind of a hassle in Jupyter notebooks. If you change something below, which like had some other dependencies on another cell, then you kind of get into a mess, like real quick. You can import other notebooks as well. You can have private sharing, and it helps you with better defaults to structure your code. But it's JavaScript, so it's like kind of different and not a replacement for Jupyter notebooks. What I use it for is mostly create some quick data visualizations, because it's built in JavaScript, and I can run my D3 code, which I usually use to create visualizations, and I can do a lot of data preparations in observable notebooks as well. So this is just a visualization that I made for the city of San Diego, looking at the zoning there. Another important and good way to use observable notebooks is to create templates. So this is a template from a journalist from the Washington Post who created an easy way to create a Mapbox marker map. And you can just put in the location that you want, customize a little bit the zoom level and everything, and you have a real map that you can create out of it. And because you can fork observable notebooks, it's very easy to create just one template and then use it all over again. I use it for my maps as well, and I will show something if I have time. So to summarize the ways that you could use notebooks, either Jupyter notebooks, R Markdown notebooks, or observable notebooks, is to understand and explain code, to share it with your colleagues. Even non-coders can take a look at R Markdown, notebooks, no matter what kind of notebooks, to use it for exploratory analysis, to create templates, and create a repeatable process. All right, let's look into a few of these examples. The first one is a kind of a fun example, which is an Enigma machine. So you might remember the Enigma machine that the, I don't know, Nazis, sorry that I can need to see that, but yeah. So the Enigma machines, and I can run, wait, I need to get out of that. So I can show, no. There you go. So you can encrypt that, and then the Enigma machine is running, which is kind of cool. So you can see how the Enigma machine works internally, which is kind of nice. And you can change even all the parameters. So that's really nice in observable notebooks. You have everything built in. So you can change here, put the labels on, and click here around to change stuff. So that's a really nice way. And this is all built in JavaScript. So you can click here and see all the code that is running this observable notebook, which is kind of nice. Another funny thing is the Dijkstra algorithm. So you can see here, click on every point, and it will run the Dijkstra algorithm and show you the output of that. Right. how much time do I have left? 8 minutes? Cool. All right. So another way, you see that I show a lot of observable notebooks. One of the reasons why I do that is because they are very easily foundable, because it's all running on observablehq.com. So everyone that shares the code publicly, it will be on one platform. That is one advantage of observable, that you can just search for that. So I can show you. Yeah, so it's very easy to explore and find stuff that other people made. So just head over to observablehq.com, and there are tons of notebooks that you can just explore and find out. It's really easy, and you can see the result and even like look into the code, fork the code, and make your changes if you want. So yeah, so it's really used a lot for like explaining stuff. So here you can see how to make a tessellated hexbin map, and someone like took the effort and wrote it all down, has Markdown in it, and then all the code that's running this thing. And there are a lot of inputs that you can just change, which should have an effect later on. So yeah. So yeah, if I change this slider here, you will see if I have, yeah. Yeah, cool. Yeah, so this is the map maker that I was telling you about, and you can download it as SVG as well if you want. So there are really great ways to do that. And they even recently included database access, so you can now use your own database that you run locally to connect to your observable notebooks and then use your database as well. Cool. Going back to the... So here are a few tools that you might want to check out. So the one is, the first two are, just collection of awesome ETL and data pipeline tools. Drake is a pipeline toolkit for R. NB-convert is an easy way to convert your Jupyter notebooks into Markdown files, HTML files, and Python code. JuPyText is similar to NB-convert, and Papermill is a great way to parameterize your Jupyter notebooks. So you can create parameters that you can then change or easily change your Jupyter notebooks. All right. Thank you very much.
That was excellent. Some really good examples of notebook use. I particularly enjoy using notebooks at work as a way of, I suppose, capturing code and outputs in the same place. Do we have any questions? Go for it. Phil.
Have you got any suggestions on tools for managing like Jupyter notebooks across like a team of people?
Sorry, say it again?
Have you got any suggestions for tools for managing Jupyter notebooks across a team of people and being able to kind of share?
Yeah, so there's one called
usage?
Binder, where you can upload your Jupyter notebooks and then share internally with your team. So it's binder.org, I think. Yeah. All right, cool. Thank you.
Fantastic. Just about be on time. That was great. Thank you.
Yeah.
You want that one, don't you?
Yes.
Yeah. Is that yours? Or?
Yeah, that's mine. Thank you.
It's you next. What do I need to do? Click present.
Do you mind putting it in presenter mode? Is that possible?
I have no idea. You drive the bus. I'll do some introductions.
Okay.
Let me just bump these up a bit. If you could stay quite close to the lectern so the mics pick you up.
Yeah, sure.
And you're from SitePen.
That's right, yeah.
Our next speaker is James Milner from SitePen, and he's going to be talking to us about WebAssembly.
Is it possible, is there any way to do split display?
I have no idea.
Is it possible to get somebody from the AV?
I mean, I would say it's a Google Slides issue rather than a...
Well, it's like, no, so you need, like, 'cause obviously most people have their notes on one slide and then it's being presented on the screen.
I couldn't say. Can we do split display? Is that possible? Yeah.
Cool, thanks, mate.
Yeah, no worries.
Oh, jeez, spoilers. I think if you just press F11, probably. Okay.
Perfect.
But then I want the notes on here, if that's all right.
Thank you for bearing with us.
Yeah. Cool. Cool. Right. Now we're cooking with gas. So, welcome to my talk, which is WebAssembly for Geospatial. My name's James Milner. I'm a software engineer at a company called SitePen, predominantly working on kind of enterprise web applications. So I used to do more geospatial stuff, and now I don't really do that much geospatial stuff. I'm more of a web developer nowadays than a GIS developer or a geo developer or whatever you want to call it. But I think there's some interesting things that I've kind of been learning about kind of being more involved in the web development community, and there's something that I kind of want to bring into the kind of geospatial community, and hopefully I can share some of that today by talking about this new thing called WebAssembly. So before we kind of dive into what WebAssembly is, it's maybe kind of useful to have a bit of a background about why WebAssembly is useful, or why WebAssembly has kind of come to exist. So for a very long period of time, people have been trying to write code in the browser that is not JavaScript. Like, people have wanted to run native code in the browser for a very long time. And the main avenue that people have kind of gone down to kind of do this is through the mechanism of plugins with browsers. So some of you might remember times when there were things like ActiveX or Flash or Silverlight or all these kinds of technologies that were based around this kind of plugin-based architecture. And kind of more recently, there's been attempts to kind of modernize this a little bit. So Google had this thing called the native client, Google Native Client, and kind of surrounding APIs for allowing you to write like C and C++ code and run that at native speeds in the browser. And Mozilla kind of had their own take on this. They had this thing called ASM.js. And the cool thing about kind of what the ASM.js approach is that you're not running, it's still just JavaScript, but basically what it does is it compiles your native code down to a very strict subset of JavaScript that executes very quickly. So this means that you can still write C or C++ or a bunch of other languages, compile that down to JavaScript, but it would be running faster than like normal kind of idiomatic JavaScript that you might just write day to day. And these were kind of the reason why this kind of became quite important to a lot of people was that JavaScript has a lot of interesting characteristics. I mean, I love JavaScript. I write JavaScript every day. But there are times when I can understand why people don't necessarily like writing big, large-scale applications or libraries or whatever in JavaScript, and that's because it is very flexible. which is kind of a blessing and a curse. It allows you to do a lot of kind of cool and strange things. So yeah, this is just like, so there's a change that's coming to the JavaScript specification to add new like operators to the language, and that will essentially mean that this will be valid code that would execute if you gave it to a JavaScript interpreter. So where does WebAssembly come into this? What is WebAssembly? So WebAssembly is kind of inspired by this desire to kind of run native code in the browser. And specifically, it kind of stems more from the ASM.js side of things, that Mozilla effort compiling just to native JavaScript. But essentially what WebAssembly is it's a binary instruction format for a stacked-based virtual machine. And I know that sounds incredibly dry, but what it actually means is that you can write code in a bunch of like lower-level languages like C or C++ or Rust, and then you can compile that down to this new instruction format. And this is really powerful because it means that regardless of like what kind of language you write in, it can kind of be compiled down to this low-level thing that the browser can just understand. And alongside this, like WebAssembly has some like kind of really interesting design goals. So one of the core things that it's aiming to be is fast. So it's aiming for near native performance. It's never going to have absolute native performance, but it's aiming to get to that level of speed. And that kind of comes from being like this compact binary format that is very quick to compile and very easy, like it just runs very quickly because it has a lot, there's a lot less steps to go through to get it running like on the hardware of your machine, basically. It also aims to be safe, so it executes in a memory safe way, so you can't end up reading like data that you're not supposed to be reading. And it's always going to be running in kind of like a sandboxed environment, which means that you can't just be like reading files or that you don't have access to, or basically trying to access things that you don't have permissions to be doing. And the last thing that it aims to be is portable. So WebAssembly aims to not have give any specific privilege to any types of like modern, it should just run on all modern hardware. It shouldn't be privileging any type of architecture or memory model or programming language. It should just be kind of this universal thing that allows it to kind of run anywhere and also be compiled to from a whole bunch of different types of languages. So here are some examples of some languages that you could compile to WebAssembly today. So the main ones that people kind of talk about are C and C++, very kind of traditional old languages. But there's also things like Rust, which comes from Mozilla, Go, which is kind of a Google kind of effort, Kotlin, which is kind of how people write Android apps nowadays, and also this thing called AssemblyScript, which is something I really like, which is so there's a thing called TypeScript, which is a superset of JavaScript, and AssemblyScript is a subset of TypeScript. So I'll let you try and, basically it's a TypeScript to WebAssembly compiler. And yeah, so there's a whole host of languages that you can write in. There's also things like Haskell, which is like a slightly more esoteric functional program language, or also .NET. I just forgot to put the logos up there. But my point is, there's a whole host of different languages that you can write in and then compile to WebAssembly. So a lot of people kind of ask me when I start talking about WebAssembly and WebAssembly running in the browser is like, okay, so are we just going to get rid of JavaScript and all the web browsers are just going to be running WebAssembly from now on? And the short answer to that question is no. Like the point of WebAssembly is not to replace JavaScript. It's to kind of sit alongside it, augment it, and kind of allow WebAssembly to handle the things that JavaScript perhaps isn't so great at. So for example, if you have very sensitive, like performance sensitive parts of your application or your library, you can offload those to WebAssembly and run those in WebAssembly. So yeah, that's kind of where it sits. It's kind of sitting alongside JavaScript with JavaScript rather than trying to necessarily replace it, or at least replace it as a whole. So currently, like, WebAssembly is supported by all major modern browsers, so Chrome, Safari, Firefox, Edge, like all the major browsers support WebAssembly. So the only browser that doesn't really is Internet Explorer 11 and below. But yeah, I'm sorry. And if you do need to support IE 11 and below, then there are ways to compile your code to JavaScript as well. So for example, mscripting, which is how you compile things like C and C++ to WebAssembly, also allow you to compile to JavaScript as when I was talking about ASM.js, this Mozilla subset of JavaScript, which means that you can basically say, does this browser support WebAssembly? And if the answer is no, then you could just ship the JavaScript equivalent. And I kind of mentioned this already, but the key thing about WebAssembly is it's kind of very good at certain things. So WebAssembly, in its current form, only really supports numeric types. So it only really supports numbers, essentially. And there are ways to get around that to allow it to handle things like strings, because you can just represent strings as their numeric representations. But essentially, it's just a really, really fast, powerful calculator, which makes it really great for things like video games, where you have lots of things like geometries, mapping, unsurprisingly, which is kind of what I'll be talking more about in a minute, because obviously, again, lots of geometries, lots of numeric operations, things like image manipulation or filtering. Anytime when you're kind of going over a big array of numbers. It's a great use case. And things like audio software, so anytime you're doing things like audio processing. So basically anything where you have big, vast swathes of data that you need to process and do things with and manipulate. Cool, so I haven't really said anything about Geospatial yet. So WebAssembly already has some adoption already today in various applications. So Google Earth now uses WebAssembly. Some of you might have seen that AutoCAD now runs in the browser. So this is actually a pretty cool story, because the AutoCAD code base is over 35 years old, which I'm sure if any of you have ever tried to look at code from last week and try and figure out what it does, will know that it's no easy feat just to port something that is a legacy code base and put it in a different ecosystem. So the cool thing about this is that AutoCAD, using WebAssembly, were able to compile their legacy code base to WebAssembly and then just run it in the browser with a little bit of glue and magic. So yeah, this is kind of just highlights the power of what WebAssembly kind of allows you to do, is take these older code bases and put them in new places. Another example is the Esri JavaScript API takes their projection engine is actually uses WebAssembly. So instead of saying to normally what you'd have to do is if you wanted to reproject something, you'd have to send a request to the server. The server would reproject all your data and then you'd receive it. But you can actually do that just client-side using the projection engine in the browser, just send the projection engine to the browser and then just run it on the client. It's pretty cool. And so yeah, I just realized everything I've mentioned is not actually open source. So let's talk a bit more about open source. So I couldn't find that many immediate examples of people using WebAssembly right now in open source. There's a lot of talk. For example, this is the Mapbox.gl JS issue page, and there's a big long issue about using WebAssembly to to be used at some point during the library. Like, how could they basically replace performance critical aspects of the library with WebAssembly? But there's like, yeah, there's basically a lot of back and forth about like, is it actually faster? Kind of, it makes things slightly more complicated, but it's looking more and more promising. So every time someone seems to post, they're basically, the whole thing is just a thread of like people posting benchmarks, and every time they post the benchmark, it just gets faster, like closer and closer to being faster than JavaScript implementation. So I think give it another year and they should have something that's faster than the current approach. And that's specifically around like triangulating geometries. So imagine if you just have a big polygon, like a graphics card only really understands triangles, so you need to be able to split that polygon down into triangles. And so they're essentially looking at the algorithm that does that and trying to port that to WebAssembly. Another example I found, I say found, this is the only reference I could find to WebAssembly in the page, but if you're familiar with like Cesium.js, which is like a 3D JavaScript mapping library, in theory, apparently they're using WebAssembly to handle like point clouds, but I couldn't find any reference to it in the source code, so I'm slightly confused about whether that's factual. But anyway, I guess my point is this presentation is not so much about like what's happening right now, but more about like what the potential is for the future, because WebAssembly is still in its kind of like MVP stage of its development. So I kind of started thinking about a bunch of different like tools that people use in the kind of geospatial field. So there's things like GDAL, which is like this library for handling like raster and vector data and converting it into like different formats. And that's written in C and C++, but there's nothing to say that you couldn't just compile that to WebAssembly and then just have it running like in the browser, or pretty much anywhere for that matter, because it can be embedded into a bunch of different programming languages. So it would allow for maybe this kind of like universal GDAL where you could just run it, like it doesn't matter if it's running on your desktop or a mobile or on the web or whatever, it could you could just have it running anywhere. And then the same kind of things for things like GEOS, which is the C++ port of the Java topology suite, and Proj, which is like is a library for like cartographic, like for coordinate reprojection, basically. And then the last thing the one I put at the top there is like GeoPackage, because I thought this was quite interesting because it's kind of this SQL-like database thing, and it's not really that necessarily compatible with the web in comparison to things like GeoJSON or KML, which are just these text-based formats which you can just read. So I was thinking like, oh, if somebody just wrote a GeoPackage WebAssembly module, then you could just run GeoPackage anywhere, whether it's on the web or, again, doesn't really matter where it is. And I had a little go at kind of doing something with WebAssembly and Geospatial. So this is so there's a library called Pixel Match, which is from Mapbox, and it's essentially for differencing images. So if you have two images and you want to know what the difference is between those two images, then you can use Pixel Match to do that. But the interesting thing is that it's predominantly used for like software testing tools to check if like there's been regressions in like visual regressions in like a website or an application. So if like a button's moved or if the color's changed for some bizarre reason. But I was thinking, well, there's nothing to stop you, like if you wanted to, what I've done there is I've just diffed two images of satellite images of London over the top of each other to do like change detection to see like when like how things have changed over time. But yeah, so that was, I wrote that again in assembly script, which is this kind of TypeScript to WebAssembly compiler. And with a bit of work, it managed to, on like a good day, I'd say it's probably about 10–15% faster than the JavaScript version. So not like dramatically, but it also has the benefit that in theory you could kind of, in the long run that anywhere. So will WebAssembly change like Geospatial? And I guess my kind of overriding thoughts are that WebAssembly kind of augments the web platform in general to do bigger and better things, and I think in turn this will kind of have knock-on consequences to like web mapping and geospatial kind of in general. So, I mean, you can do things like compile libraries from different ecosystems, which I've kind of talked a bit about already. In theory, you should have more performant code for like very data-intensive parts of your app or your library. And also, like, you could have compile native applications or native libraries like to the web. So, like, allowing the web to do things that would only have ever been done in kind of the native application space. But also, I've kind of talked a bit about this already, that this WebAssembly is just kind of aims to be this universal thing, is that, I mean, there's a possibility that in the long run you just have one library for everything. So you just write, instead of rewriting GEOS or Proj or GDAL in C and C++, and then someone rewriting in JavaScript, and then somebody decides they want to write it in Rust or whatever, it's like, well, we just have it written in C++, compile it to WebAssembly, and then you can just use it wherever you want. Which is a pretty like cool idea to me, at least. And I mean, so JavaScript is quite old, and it kind of has developed this whole ecosystem around it of like, it doesn't just run kind of in the browser, right? Like JavaScript runs in the back end via something called like Node.js. You can run it, there's a bunch of like frameworks for running JavaScript applications on mobile devices, of which you can like cross-compile like to Android or iOS. There's this whole like ecosystem around it that's just kind of developed because of its ubiquity. And I think like there's a very strong possibility of the same kind of thing happening in the WebAssembly space, where there'll be this whole ecosystem of tools and ways of doing things that are only possible because of WebAssembly, and grow in this ecosystem like around WebAssembly. Yeah, I think that's me. Thank you very much. Yeah, that's fine.
Thanks very much, James. We need to move on. We do not have time for questions, but I would like to welcome to the stage our next speaker, and hopefully I'll be able to change this over relatively painlessly.
Okay, sure.
This one. No? Not doing? Yes, please come and drive.
First of all, thanks to James for softening them up. It is, after all, the getting technical track.
On up. And do you want it down here as well?
Yeah. Oh, yeah. Yeah. That's
yes. Almost a given. We've lost it. Oh no, there we are. We're grand. Cool. Yep. So I'd like to welcome to the stage Dennis from Geolytics. Yeah, and this one works as well.
Oh, cool.
They both. Yeah.
Right. Right. Thanks for the introduction. I know we're running a bit late. I'm trying to keep it swift. Also have the benefit I'm doing this talk the second time. Some of you might already have seen it at the FOSS4G in Bucharest. This, however, is the FOSS4G UK Edinburgh edition. I did a couple of changes, so please stay if you're already seeing it. Right, composing and securing spatial data interfaces. When, why, how, the serverless edition. The serverless processes, of course, do use server. So, in order to get the catchy cloud edition in, while really it would be function as a service, I take the why straight away. Pay per usage. That's why we have it. Less maintenance. Well, less maintenance in order means machines do not maintain themselves, yet humans maintain machines and humans want salaries. So it's again the same principle. It's cheaper. Scalable. Scalable is pairs usage. So You have 10 instances, you pay for 10 instances. You want to scale up at a time to 20, then you pay for 20. Again, it's cheaper. High availability, same thing. You pay for performance. Yeah, you can have like a better, a bigger machine, but having more machines, which are less fault tolerance, it's cheaper. Okay? Okay. Why OSGeo? Well, Joe earlier did already a fantastic welcoming talk and telling us about all the great benefits of OSGeo. Mine is a bit more simplistic. OSGeo is an organization for people for whom open source geospatial technology is a drug, whether they are making, dealing, or using. I think James earlier said it very well. He used to do it a lot. Now he doesn't actually do it anymore, yet still he's here. And what did Bill Hicks say? Not all drugs are good. Some are great. I'm your pusher in that scenario. But there's no I in team. Our team is Geolytics, who are also silver sponsors here. And we are location planning experts, meaning we do consultancies for retailers or other big businesses who have bricks and mortar stores, who have like doing business at a certain location. So we are not a software vendor, yet we're making open source software where we build the spatial data interfaces really for ourselves, and we're opening it up. Great deal of opening it up is thanks to our CEO, Blair. Sorry, we're in Scotland. Our captain Blair, who's really into open source. He's also here at this event. And without his commitment, the rest of the talk wouldn't have happened in the way it happened. Right, location, location, location. Location intelligence involves layering multiple data sets spatially. So that's really the two components, locations and layers. Many locations can be on many layers, and we interact with them. What we really do with them is we capture them, we create new locations or modify locations. We analyze them, meaning we're looking at the location, how they're in relation to other locations. And then we compile our findings, the analytics, the modeling, and create reports or views in order to disseminate the information to other people. A location is the cornerstone of any spatial data set. As I said, it can be grouped into layers. And at the core, a location has a geometry. Now, it can be either a point or a polygon, and it has additional properties. So the perfect description of a location is a feature in a GeoJSON. So here we see like a feature collection, and one of these features is a location. In this case, it's a very simple one. It's a point. It only has a coordinate somewhere in London, and it has a category. It's a Marks and Spencer store. That makes up a location. Now, we can have different views. In this case, we have more than one retail point, more than one store, and we have two different views of exactly the same spatial data set. It's from our free open source retail points data set, and it's somewhere in London where we clustered up stores. On the left-hand side, we show it as a map view, probably the most common. On the right-hand side, we show it as a table view. It's the same data, but the table doesn't show the spatial component, but only lists the categorical, the properties. Methods, very important for the interfaces. Methods or operations is how we interact with the data. So at the very basic, on a systematic level, those are the CRUD operations: create, read, update, or delete. These have different lexical terms dependent on your environment. If you're a data scientist, you will work mostly with SQL and use insert, select, update. If you're a web developer, then you will use HTTP commands like put, get, patch, delete. It doesn't really matter how you name it. The important is it's a very few basic operations. And these operations really make up an API. And for those who've been in the business a long time, you will remember SOAP. Well, SOAP's really been a pain in the API, and thankfully, Dr. Fielding provided us with the REST IFC 2616 standard. And there are a few constraints, and all of these constraints are really important for any API or any interface. And the first one is the client-server separation. So you, the client who interacts with the data, all the interaction with the data, the processes, shouldn't be run on the same machine, but on a server, or a serverless not server. They have to be stateless. You don't want to be connected to one server and only work on that one server. We're talking here about processes, so every process should be ephemeral, like very short. Same goes caching. Caching is very important. You look at Google Maps, it's so fast because a lot of the data is cached. So when you request a map tile, you don't want to request a map tile again. It's already in the machine, it's already cached. The same goes for all the other resources such as images, icons, all of these can be cached. And very important is the uniform interface. The uniform interface, that's HTTP. That's like a method, that's GeoJSON. It's just a format. So in order to talk, let's say, to a PostGIS backend or an Esri backend, we all use the same, well, Esri doesn't, but most of us use the same open formats, so it's very easy to integrate different systems into one interface. The layered system, it's quite important for security, so calls will go through several layers. I will talk more about this a bit later. Code on demand, it's a very complicated constraint, and I don't have the time to go into detail at this point. But this is the meaty one. So this is the main system diagram of the XYZ, the original GeoServerless XYZ project, which we developed at Geolytics. So we separated the system into 3 distinct parts, which is the backend. That's where the data at rest sits. And so it's not just the data as in terms of the spatial data, but also ACL, something like access control lists and workspaces, which describe how the data is composed. In the middleware, that's the Node.js middleware, that's like the runtime. That's the RESTful API where the calls from the front end come and do things with the data, request the data from the back end. So it's very important. There are 2 types of endpoints. Either there are functional endpoints, you can get code on demand, or there could be static endpoints where you request a resource like an image, a template. What you can request is defined by the workspace. So it's the same workspace in the backend, it's just read into memory. That goes for the front end as well. And very important is the environment. So the environment is the environment in which the Node.js runtime runs. In there are secrets, like stuff you wouldn't tell anybody, like what's your key for your Mapbox account, or what's your Google Maps key. So we see in the bottom, in the cloud, are all the third-party services. They can obviously call directly from the front end, but we prefer if they're called through the middleware, where the key is stored as a secret, and the middleware acts as the proxy. On the front end, that's the control libraries. So, like the map control library, which controls how a map works, how the other objects are defined, so a layer object, a location object, the views, the dashboards, which you can see in the browser. And of course, there's also the workspace in memory. So, the backend. Postgres, obviously. It's not too much to talk about. I'm pretty sure all of us have been working with Postgres a lot. It's really the only choice if you think about spatial data. The problem is it used to be the bottleneck because it has to run on a server. Serverless Postgres wasn't really that easy to do. It's not easy yet, but it hasn't been so much a problem for small-scale operations like ourselves. Like we have applications which are used by 10 users at most at the same time. It becomes a problem if you want to have like hundreds or thousands of users at the same time. And scaling, geographical replication, and backup is really hard. I can only recommend you at this point second quadrant who are here, because we really run into trouble and we are customers of second quadrant and they're helping us with all these really hard bits. However, the other XYZ by here, they are using Amazon Aurora and have been talking with them, and the idea is really quite smart. So you have the data in storage. So that is, it's self-maintaining storage. So where the data sits, and if there's a problem, it heals itself. And the actual database cluster, the PostGIS engine, sits in a pool. So this proxy fleet, which takes requests from the application, finds the nearest warm instance of a Postgres cluster, and that takes your data in from the DB storage. So that is great. However, the data API, Amazon says really easy to use. It is not. And the simple notification service, SNS, is anything but simple. There's also an ethical issue, so I can't really go into detail, but if you look for How I Make Jeff Richer by Paul Ramsey, he explains why Amazon Aurora Postgres is not really Postgres, it's a fork, and there could be problems that in the future maybe some features are only written for the AWS flavor of Postgres, and they're not going to benefit the wider OpenGeo community. My favorite part, the middleware. So the middleware is, it's Node.js, and it's great because I believe everything that can be written in JavaScript will eventually be written in JavaScript. And in particular, there are two really, really great features of the middleware of Node.js or JavaScript in the middleware. The first is the middleware pattern, the middleware onion, which, as we talked earlier, in the layers works exactly like that. Every request goes towards a handler, which is the core of the middleware onion, and has to come as a response back to the user. So one layer could be security. One layer could be requesting the data. Then the handler processes the data, and it all goes back again to the user. Another great feature is the lambda function. So the lambda from the Greek lambda calculus is just a small running function. It's an anonymous function. It's a very abstract one. So this lambda can be a process which does one thing and one thing only. In this case, the process is the whole middleware. It is a HTTP server and router, and what it does, it listens. It listens to requests, and when does it finish listening to requests? Never. So it's a long-running, scalable process which can do all the things. So there are, of course, modules such as user roles, JWT, which are used by different endpoints, but every endpoint is within the same process managed by Fastify. And the XYZ now here refers to we using Zeit now to deploy this process. So there we can say, here's a process, and it just works. And it's really, really cheap. That's why we use it. I think in the early days of Zeit now, there became criticism for being too cheap. And people said, it cannot be good if it's that cheap. It's kind of like the reverse Ryanair. It has to be cheap because it's not good. Right, going on with the environment settings. So the environment settings, as I said, these are all the secrets which tell the middleware what they can do or can't do, and how to talk to third-party services. These keys are obviously all randomly generated, so you don't need to take screenshots. The workspace, as I say, that describes the structure of the spatial data. That tells the interface which can be done. So at the top is the locale, which could be a country. It's just a regional definitions. And in there are like the layers, and the layer have formats, geometries, where the data for the layer sits, how it should be styled, what the location is. I'm going to go really quickly through the anatomy of a request, since we're running a bit out of time. So that's a request to the interface. In this request is the JWT token. So that's a real token which expired some time ago and tells the application who I am and which roles and rights do I have. So the middleware checks the token signature, knows it's a valid token, and validates the query parameters. So that's one of the layers in the middleware onion. Another one is to check the roles. And once all of this is good, it actually does a SQL query. So the SQL query is never sent from the client to the middleware. The middleware knows the SQL query because the SQL query is stored in the workspace. So I can only say, I'm this person, I have access to this query stored in that workspace. Please execute for me that query and send me back the data. And then you get the data back to the client. Ideally, in the future, these will be microservices, so that each handler is a single microservice, each module is a single microservice. Now, there's a lot of benefits of doing it this way. It is, however, a lot harder to do. We would need to use like a microservice like micro or MIDI. And we haven't done it yet, so that's really the future, what we want to do. There's also another big problem with cold starts of these microservices. Just creating a database connection takes about 200 milliseconds. Now, there are ways around using the SNS, the Amazon SNS, where I put my constants, the variables with the connection outside of the handler, and those stay warm, and I could have like the MVT service, which is the topic, and then the other endpoints which request the MVTs. And once the MVT service has already the database connection spooled up, all the requests are fairly rapid. I think it's about 10 to 20 milliseconds. Again, it's what we're building at the moment. Another option is serverless. So serverless is just a framework which helps you deploying to Amazon AWS and other cloud providers. It's basically, it manages how the lambdas talk to each other. Site Now version 2 is another option. So Site version 2 works the same way. However, there's a builder involved. So that builder takes your monorepo, your middleware, and splits it up all into microservices and tells these microservices how they talk to each other. It sounds really great, but if you look into the forum for Now V2, you see mostly that reaction because it doesn't really work yet, and there's a lot of angry feedback. Plus, you can no longer sign up to Site Now version 1. However, we are signed up, so if you need the services, we can provide them for you. Lastly, the front end. So the front end, that's what you see. That's a dashboard. Here we have these multiple views combined. So we have like layer views, a location view, a map view, and a table view. They are based on this x_xyz object. That is basically the object which knows exactly what to do on the interface. Again, a map view, it's easily created. It can be pushed into an observable HQ. And as we've seen earlier, in this case, you just drop the map in, and then you have all the other objects like, sorry, I'm gonna quickly have to skip over that. So we're using open layers. We used to use leaflet. We now move to open layers. Mapbox GL is possible. I wanna go to the layer object. So the layer object, which is defined in the map object, has like methods like getting data, how to style the data, be turned on or turned off. And in this layer object are the location objects. And the location objects have methods such as edit, update, meaning sending the information back to the middleware and then to the client. So in this case, my favorite location object, the fatherland. Filter objects, as well as style objects, are again, like they're very simple. They need to have a common interface. So in our case, we just have like the basic types, Boolean, match, like, greater, in, not in, ni. I gotta have to really run through this, I'm sorry. So the custom endpoints. Custom endpoints is basically, you ask an endpoint to serve me up a template which is not stored in the middleware, but for example, it's stored on GitHub. So all the HTML, CSS, JavaScript is received from GitHub to the middleware. In the middleware, we use serverless site rendering using this library JS render, which was written by the same person who did the jQuery templating engine. So that template is then sent to the browser, and you have a complete custom view and look with the same functionality as the default functionality. So here's another example, which hasn't been done by us, but I gotta have to finish. If you like it, please go to our Geolytics XYZ on GitHub, give it a star. We go from here, GeoMob London, I gotta have to whittle the same thing down to 10 minutes. Hopefully I see you all 2020 FOSS4G in Calgary. And we want to become an OSGeo project, which requires, well, your input, because if I get run over by the bus, then that wouldn't be good for the XYZ project, and OSGeo doesn't like it. My last slide, just the details. Well, our website, Geolytics UK, please check out our GitHub. Debouts XYZ, that's my medium, which I write about all the updates. At Goldie Digital is my Twitter handle. Thank you very much. Enjoy lunch.
As you might have guessed, we've run out of time for questions. If we could thank all of our speakers again. I think John and Dennis both have stalls upstairs, so if you want to go and grab them. Yeah, feel free to go and get some lunch and speak to everyone that you haven't managed to catch up with. So thank our speakers again.
stay here for the... You do. Professional. I'm going to be constrained though. That's the issue. Mm-hmm.
Hi, welcome everybody to this session on data and discovery. We've got Alistair from Registers of Scotland who's going to talk to us. So I'll just let you get on, Alistair.
Okay. Hello everyone. Hope you enjoyed your lunch. I did. It was very nice. I'm going to be talking about it's a number of concepts actually, but it's more of a story rather than any specifics. And really, we've given this the title Land Registration Using Open Source Software. I'm not really going to go into the specifics of that. I think we don't really have time to delve into the depths. If you want to chat about anything in here, stick up your hand halfway through. Quite happy to answer some questions. Or we have a number of people from registers here that can go into a little bit more depth if needed. So if you don't know who Registers of Scotland are, we are the Land Register of Scotland. We currently hold 20 public registers relating to land and property ownership in Scotland. The two big ones are our property register, the CC Register and the Land Register. We'll talk a little bit more about them in a minute. We have 6 others that kind of focus around land. An example of that is the Register of Community Interest in Land, Site of Special Scientific Interest as well. And we also have 12 judicial registers. Registers of Inhibitions is one example where you can block property sales, to the more exciting end of those registers, like the Register of Hornings, where we publicly denounce debtors as outlaws. So, as I said, the main body of our work is based around the 2 property registers within Scotland. Scotland's got a very long history of land ownership and public registration, and really all built around transparency and openness of land registration information and property information. The Register of Hastings has been around since 1617, and it is the oldest land property register in the world. Not really had any challenges to that, but we're always open to some. Being Scottish, yes, come ahead. That is a register built around deed registration. So there's very few plans or maps, and didn't really appear until mainly in the mid sort of Victorian period. Kind of moving the timeline on to, and that register's been running and still runs today. Moving on to our spatial register, the Land Register, which is built around the register's title. This is the Torrens system for anyone who wants more detail for that, and really built on the English land registration principles. Currently we have, and that's a completely spatial register built on Ordnance Survey mapping, titles guaranteed by states. And that register was amended quite recently in 2012 to bring it more into line with Scots property law. We currently have around 64% of Scotland's landmass within the CC register. That's obviously an issue because most of that's not on a map. And around about 36%, if you're good at maths, you'll be able to see spatially. Now with that sort of split, it's quite obvious to see that most of the rural areas within Scotland aren't actually covered. We've got a high proportion of the urban areas, but most of the rural aspects of it. So that's kind of the end of the story for Registers of Scotland for quite a long period of time. Quite happy just to register land and do things that we've been statutorily obligated to do. And it's only been quite recently where that's changed. We set off the Gateway Discovery project to really start talking and conversing with our customers. And actually starting to understand how they use registration information, how they interact with the registers, how they gain access, and really understanding how they perceive us in the conveyancing process. And that had a number of really interesting insights. for me personally, looking at the spatial side is really the bit I want to focus on today. Now from that, it was really about getting back to the basics of openness and transparency within registration information within Scotland. It's something that's not really been there when you're looking at a process and systems that are really there to support single entry paper documents and paper title plans. So our corporate plan was really built around getting us into this modern age. So we decided to accept the challenge of trying to complete the land register by 2024, get everything on there spatially available. Straight away allows more transparency, delivering some digital improvements for our customers, really improving access more than anything, and trying to innovate around land and property data. And really one of the obvious things in there is investing within the staff and the skills within our building. First step to that was that part about giving transparency to the register again, giving access, giving public access. And this is a journey. It's a stepwise journey that we're taking. So Scotland was the first part of that, which is really just to give a view on the register that hasn't really been there for the last X number of years, and certainly not in the last 20 or 30, unless you came into one of our customer service buildings. Just as an addition there, completely built on GeoServer, open layers, and Postgres. Again, that's another stopping point. It's only part of the journey. As a government body, we could have just stopped there and said, well, there you go, you've got your access now. But it doesn't really go far enough. And that's really been based around, I suppose, the main task of the work that I'm involved in. And it really comes down to this thing here. And I've tried to go with a real 90s feel, because this is where this piece of technology comes from. And this is a piece of technology that's still in our building right at this moment, and actually causes all of the issues about giving access to our land register. Built in the early 1990s. I was hoping you'd like that. Built in the early 1990s, it's absolutely fantastic at producing and printing and making paper maps that go into paper land certificates that you buy and sell your property on. But as the Gateway project talked about, our customers are asking more. We're in an age now where we want more than a paper document at the end of this process. It's not just for the house owner or the bank to gain access to this information. There's a lot more uses in there for that as well. So number one task is get rid of this thing. And we're pretty much on the way to doing that. Part of that is what we're calling the cadastral map, which is really about front-end tooling for our registration process, and the back end, a new land registration system that supports all of these wonderful things up there, and actually helps drive towards some of our strategic goals around completing the land register and really providing diversification of land and property information. At deeper level, that's a documents to data journey, where we go from those paper documents, those plans with shapes on them, and start giving something more meaningful. So the red edge, the classic red edge on a land certificate now becomes an ownership polygon. That suddenly becomes much more useful and much more accessible for other uses than just land registration. It's not a straight timeline. We're somewhere in the middle of that just now. The basis of that, again, is building on a really strong model and open, and really looking at open standards and not just open source software as well. And we've built around this opening statement within the 2012 Act, which is there's to be a public register of rights in land, and building around the rights in land, defined in land, that are recognised to things. Built around the ISO standard for land registration information. We're using GDS principles in here about being open and using open source. building around open standard principles. And we're really looking at a whole suite and raft of open source products to support that. The big ones in there are really where we're storing our data and how we store our data. And that's really been the key to everything that we're looking at. And it's front and center within Postgres. So how do we benefit? From our point of view, we're looking at our data, and that's really been the key to everything, is ensuring that we're custodians of our own data. There's no locking through proprietary systems. That allows us to cooperate much quicker and easier with our customers and other software vendors. It becomes cost effective. It's much easier to experiment when you don't have to go through procurement and procurement process, looking at extra licensing, etc. And that allows us to drive change in value within everything that we provide as well. And from the other side of the fence, how do our customers benefit? We're actually slightly faster than we have been previously at providing new products and services, and actually getting on that journey of answering questions and that customers want to see. Again, it comes about cooperation, trying to provide more openness and transparency to the things that we do around mapping. We've got a number of things that we've been involved in recently, the open standards for mapping in government. We've been sponsoring as many open source conferences as we possibly can, just trying to get involved in the community. And we're always open to anyone who wants to come and see what we do. Following best practice and standards, not just within our data, but within UX, accessibility, and products and services as well. And again, being able to drive that change in value. I suppose the end part of that is really about just making mapping easier, just making accessibility to maps and spatial data much easier within the land register. And that's all really built on the open standards and open source software that we're using. Okay. That's enough of me talking. Does anyone have any questions?
Questions from the floor if there is. There's one down here.
Yep.
You just walked past.
Sorry. You mentioned the use of stuff from the early 90s, back when I was in middle school. Is there any plans for, say, support going on for some of this stuff for 20 years? Or to make sure that, the one guy who originally wrote a section of software, God forbid he gets hit by a bus, and suddenly you have no support for that sort of thing, to be able to keep making sure that you can support this software going forward until someone so kind enough puts forward the money to write it anew.
I think you basically just gave insight to how things have been, I suppose, how our infrastructure has looked over the last 30 years. When it's almost in a kind of moon landing situation where we don't have enough of the people around who built or did that task. And it was really getting to the crux of the point of there's only a couple of people left in the organization who actually even remotely half know how these things are put together. So this is why the retirement project is, I suppose, accelerated and gained the funds it needed, because we had to get rid of this equipment. It became a burning point of task.
The infrastructure, both people and,
and
facilities, to make sure that you can make sure that that's
and
continuing.
it was the drive around again avoiding, because this is a completely proprietary system, so avoiding that lock-in. When you approach that organization who built that piece of software and they don't have people in their organization who understand it, and again it goes back to some of the GDS talking about open standards and open code, open source. The more people involved with it, the more the community that you can build around what you do, and the more you can share that across not just other cadastral and land registration organizations, but we're talking about national mapping agencies using the same software, building on the same databases. It makes sense to go down that route.
Yeah, I was pretty much following on. I just want to ask whether you plan to do the whole development in-house yourselves, or you plan on tender for individual components to the industry, also working together with other countries. I mean, every country has a registrar in some form.
Yeah, and again, I mean, we're using Agile completely within the organisation. We have our own development teams now as a mix of contractors and permanent staff. And again, when you're talking about using open standards, by picking an open standard, it allows those smaller players within the industry to immediately be able to be involved with us, rather than relying on proprietary systems and proprietary standards where only certain companies can involve themselves with that. So yeah, keeping the open standard and that open approach allows us to interact with everyone, or as many as possible.
Any other questions?
Quick question. You mentioned like giving to like open source community and all the rest.
Yeah.
Like giving to open source communities as a government organisation. I find it quite difficult because we're coming from the same sort of place. It's like I have to make quite a weird sort of business case to even consider donating. It has to be a business proposition sort of thing.
Yeah, and I think we have to be careful. I don't want to be disingenuous about what we can and can't do, because there's things that we can't do, and those are things that have to be sorted out over a longer period of time, and that involves most of Scottish Government or the UK Government to sort these out. So where possible, we will try and involve ourselves as much as we possibly can. I think probably the best thing we can do is use these products and show that they can be used at this scale and for essentially public good use, and sponsoring as many events as we possibly can.
Yeah, it's just trying to make a monetary case to, there's not like a clear benefit situation where you're giving to the open source community.
Yeah.
You kind of have to make a business case, and it's very difficult for me to try and make that case.
Yeah, we could chat after, just about establishing value if you want.
Thank you, thanks.
Okay.
That's really interesting to see the journey that you've had to take. Welcome, Alison. And Alison's going to talk to us.
I need to unlock the laptop.
Once we've done some technical stuff down here. Passwords in.
Remember from earlier.
So Alison's going to talk to us about our Falkirk, looking at the impacts of poverty using OSM.
You did break it.
That's right.
No, that's not.
Okay, that's awesome.
Hang on. Oh, no. Oh. It was there.
Oh, all right.
Yeah, if you...
Okay. No problem. Right, I'm going to try and stand so you can hear me. I hope that's okay. Okay, I'm here today to talk about a project, our Falkirk, that Thinkware was involved in with Falkirk Council and the Fair Falkirk team there, who deal with looking to mitigate the impacts of poverty in the Falkirk Council area. Our Falkirk being a kind of online tool where people in poverty could find out about support services in their area. The tool was developed using open source tech and centres around the use of open data. In this case, we're talking about OpenStreetMap data, which I'm presuming everybody's familiar with, but essentially it's a kind of crowdsourced data set where contributors globally can add their own data features and tags, which are attributes. And it's a really exciting source of data. Big sort of slot in terms of time today, so I don't know what time we'll have for questions. I am upstairs afterwards, but I'll put up a slide at the end of the presentation with various links, including the GitHub repo, our ThinkWare public GitHub repo. So any of the code there, you know, you can go in and you can have a look after the event, and there's various other kind of sort of links and resources. So if we don't have much time for questions, hopefully that will be useful too. Oh, this one. Okay, so just to give a bit of context, this is information that comes directly from the Fair Falkirk team. Essentially, in the Falkirk area, 1 in 5 people live in poverty, which sounds drastically high to me, but apparently that is, you know, on a par with the national average. Where poverty rates exceed those of the national averages in child poverty, I think about 27% of children in the Falkirk Council area live in poverty, due to a number of factors, but partly the fact that they have a lot of young families kind of living in the area. So obviously that's quite a statistic. Those children will be, you know, feeling the impacts of that poverty in terms of, you know, being cold, going hungry, not being able to take part in activities with their friends. But also we know that childhood poverty kind of impacts on aspirations and achievements and health in later life. So, so quite worrying statistics there. It's also just kind of again to give that context in terms of poverty in the area. You know, contrary to sort of certain misconceptions, there is a lot. It's not necessarily about worklessness, and as it says here, 58 of people in poverty in the area live in a household where somebody is working. So there's a good deal of in-work poverty as well, which is obviously, you know, requires sort of structural changes, implementation of the living wage, that sort of thing to deal with. Another sort of factor of it is that in terms of poverty rates, these look set to rise, and the team estimate that £62 million a year will be lost from the Falkirk economy as changes to the social security system are rolled out. So that's kind of just to provide a bit of context. So what I'll do, sorry. Over here. So the Fair Falkirk team, they recognise, and the council recognise through their strategy towards a Fair Falkirk, that they're not going to be able to lift everybody out of poverty. But what they can do is they can seek to mitigate the impacts of poverty on individuals. And so to achieve this, the strategy sets out 4 key aims, the strategy recently being refreshed for 2019 to 2024. And there's 4 key themes to it: fairer access to services, fairer culture, money, and childhood. And there's a sort of action plan that sits behind that, which details the steps that would be taken to kind of deliver across each of those themes. So in terms of fairer access to services, that's really kind of, I suppose, where this project is focused. Obviously, services there are services out there that provide access to food, digital access, other sort of community support services, and these are really key to those facing poverty in terms of giving them sort of practical day-to-day help. So, just a quote from the strategy, which I think is quite telling here. Poverty being both a cause and a consequence of poor access to services. So they estimate that the cost of being poor runs to about £490 a year. And with better access to digital services, you know, they can help to mitigate that. So that's access to things like being able to shop online, being able to find better utility deals, deals on your mobile phone, that kind of thing. And there are a range of services out there available, like I say. I think the challenge is to sort of collate all that information, bring that information together, package it up and serve it out to the people that need it in a way that's sustainable and flexible, and also cost effective. So there's a challenge there. Sorry, wrong one. I'll hold this. So in terms of, the project origins, really stem from the ODI, who I think it's 2017 opened up, or last year, sorry, opened up their new data stimulus fund, trying to encourage better and more innovative use of open geospatial data within local government in the UK. So, you know, we were keen to think about how we might be able to kind of work in that space. We are an independent web mapping and GIS consultancy, but born out of local government. We were a shared service for 3 local government authorities, including Falkirk Council, until 2007, when we spun out and became a private company. We also deal sort of more specifically in open source GIS technology. So in terms of, this is the map cloud, that's our sort of core platform. That's, you know, the full stack of PostGIS, GeoServer, etc., etc. And we also work quite extensively with open data, and also more specifically in terms of this project with OSM. So a couple of years ago we worked with the humanitarian OpenStreetMap team to redevelop their hot tasking manager. You know, we run missing maps events sort of really regularly. And so we started to think about the problems associated with effective data sharing in local government, and to think about the potential for OpenStreetMap to be used to open up access to information about services to local communities. And at this point we approached Falkirk Council and their Fairer Falkirk team with an idea which, thanks to the ODI funding, then became the Our Falkirk project. And really the aims of that project were simple. For the Fairer Falkirk team, they were really just looking for a simple web app that they could use to make information about local services available online. So it's both to the public, but also crucially to frontline staff, who are then better able to signpost people in need and facing the impacts of poverty to the services that might benefit them. So in terms of how it sort of fits together, the central idea really was to just create a really lightweight application in which all the data on the map, the background mapping and the feature data comes from OpenStreetMap. So that essentially means there's no need for the local authority to store and manage and maintain that data themselves. Basically, in terms of OpenStreetMap, you just need a browser-based tool and a little bit of guidance in terms of how to get started, and then you can start contributing your own features, updating tags, which is basically attribute information to OSM features, and you're away. So, as I said, really lightweight solution. Like I said, I won't go into a lot of the technicalities because but the code's all there on GitHub if you want to take a look. It's really quite straightforward, written in using the React framework. It's hosted on AWS, and it's really lightweight. You just need somewhere to host that website. No database, no DBA, that sort of thing. So it's really trying to tackle the sort of challenges of you know, burdens of sort of IT infrastructure, the need for specialist skills, that sort of thing. So the idea here is that the members of the team, but also potentially the public, can keep this data set alive. They can keep it up to date as new services are brought online, as details of those services change, and as services kind of disappear. So the themes that we settled upon were, well, this was essentially the themes that the Fairer Falkirk team and their partners settled upon, because they did quite an exercise to kind of really draw out the types of data that they wanted to be able to present, the types of services that would be of use, and they settled on these 4 themes. So basically the application kind of organizes the data within these themes, and that's how they're displayed to the user. Within OSM, we use basically a theme as a sort of logical grouping of tags that suit a particular purpose, and these are the themes that apply in this purpose, but that idea of a data theme could extend obviously much more broadly. So the council kind of worked together with its partners to find the types of services that might fit within these themes, the types of information that they might want to be able to display. So if it's digital access, okay, that might be at a library. I can go to the library, I can use a computer, but do I need to be a member of the library? Does it have Wi-Fi? Is there printing? So they wanted to think through these things to make, and then from that we could build up the sort of tagging schema that we were going to use to define these themes. So this is kind of the next step, looking at the data that's already in OSM, how we build and add to that, how we define the tags that we're going to use, and really then enrich the OSM data to be able to display all the various services that are relevant. Some of it needed to be a little bit creative. So, for example, a food bank may be sited in a church. So the feature, the church might be in OSM already, but we might create a second feature for the food bank because the sort of the attribute information, the tags we might want to associate with that are different opening hours, that sort of thing. So this, you probably won't be able to make much of that, but essentially it's just to kind of give you a sense of the process of really looking at what tags are currently most commonly used. We went through quite an exercise in terms of just defining down the most appropriate tags that would have the most resonance elsewhere also, and also deciding what new tags we might need to add. And the OSM community provided lots of guidance and really helpful insight in that process. So then once we have the themes defined, we then can create our theme config file, which essentially then says when you want to display data for this theme, you need to use the sets of tags. So I'll show you this here. So this is also, again, very tiny, but basically, essentially, the config file for each theme is like a schema that we've defined, which basically sets out the purpose and the purpose of that theme, the tags that apply to it in terms of these are the features that fall within this theme, these are the attribute tags that may apply, and then also how to kind of present that to the user. So this is our food bank, or it's our food provision theme. So within that, there's, if something's tagged as a food bank, then obviously that comes through. In terms of the attributes here, basically these are defining the attributes that if they're there, we want to be able to present to the user. Obviously, working with data where you don't control the content and the schema, you have to be flexible to do that. So, and here is the query that we use to actually dynamically bring that data into the application from the OSM dataset. So we use this overpass query. It's just an API that we can call upon, but it's sort of particular syntax. So that's sort of stored within with the config file. And the idea is that, using this schema, we can define a theme, and then we can share that theme with others if they're, and they can use and adapt and create their own themes. So this is just showing you the application. It's using that theme config file. It's pulling down data that match those particular tags, and then using the config file again, it controls how that information is displayed to the user. So I don't have time to do a demo, but like I say, the link's at the end, so you'll be able to see the application. It's really straightforward. It's supposed to be really straightforward and intuitive. Doesn't really need a lot of explanation, but essentially the data's kind of grouped by these tags. You can click on a point, identify the information that will then help you actually access that service. So in terms of sort of the key outcomes, basically from the sort of Fair Falkirk local government perspective, I think the key thing was that by sort of freeing up the need to sort of manage and maintain their own database and the infrastructure around that and the skills around that was sort of overcame a challenge for them, but also being able to, just as users being able to go in and update the data, add new features, that sort of thing. It was, in terms of creating a new theme, that still requires a bit of skill and knowledge in terms of working out what tags to use. It's still a bit of a manual process. But just in terms of those IT overheads and the ability to just use browser-based tool to update your data, that was a real sort of win for them. And in terms of sort of OSM and the open data perspective, I think the idea of having these themes that you can use and reuse and share, defined with this lightweight schema, is something that, you know, could be taken forward, certainly. So in terms of where this might go, obviously the FOSS4GUK team are really keen to expand the audience. They've got lots of ideas in terms of how they might enhance the data content that's there, additional themes, you know, furniture provision, seasonal activities, so, you know, Christmas, kind of food projects, school holiday programs, that sort of thing. And there's a lot of ideas that they have in terms of how they want to take it forward. In terms of OSM and wider community, there may be appetite to look at theme creation and providing tools to really help with that process, so that you can. I still think you would need to have a bit of knowledge behind you in terms of being able to look at what tags are currently in most common use to describe certain types of features, but being able to use a wizard or some kind of tool that would allow you to specify what your theme's about, the tags you want to use, the kind of attribute information you want to specify, and how you want that displayed, and then it would create that, populate that sort of schema for you, which you could then use, share, amend. And also, as I mentioned, the code's available on GitHub, so I think the idea would be, ideally, that people will take this on and, create their own implementations. I know it has been trialled. I think there was a Bath Hacked event earlier in the summer where they were trying to get this going, or they did get this going, and so yeah, hopefully the code, now that it's out there, will continue to evolve and be used. So these are the resources that I mentioned. I'm going to stop talking now because I think I've pretty much had my time. I must say a big thank you to Sally Buchanan and all of her team at FOSS4GUK, who put a lot of energy into the project, and also to Jez Nicholson, who may or may not be here, but from OSM UK, and the community in general, really, who were also extremely helpful, just in terms of working with OSM and tags, and how you define new tags and get new tags kind of accepted within the community, or proposed and accepted within the community. It was really helpful to have that kind of support. So I'll leave that for you there just for a second, but yeah, if there's any further questions, if we don't have time for them now, please grab me at the end. That's me.
We're slightly short on time, but we can maybe take one quick question if anybody's got one. No. Well, we'll catch Alison later if you've anything else to ask.
Yeah. Thanks, Chris.
Okay. Hi, so just wait for people to come in and out.
If you need to get my stuff on here.
You got it.
Yeah.
Getting it okay?
Mm-hmm.
Okay, so just going to introduce Jonathan from Lightpair, and he's going to talk to us about Geosphere, a search engine.
This is what happens when you use open source software. Maybe.
Yet.
PDF version as well.
You can duplicate the screen if it's easier for you.
Please.
Let's do that instead.
Which one's that?
The Windows P.
P, that's what. Excellent. Full screen is not F11.
If you try function, like the function F11 might.
Hello, sorry. I'm using, ironically, open source software for presenting my presentation, LibreOffice, and it's not working. So, bad start. I'm Jonathan Moles. I'm here to present Geosphere, which is a search engine for geospatial web services. How do you do next page? It's going to be page down, because it's PDF, sorry. The backup option. So, I'm going to be talking about why this is a problem, what I'm trying to solve, tell you a bit about Geosphere, the solution, I like to think, a demonstration, that should work, and some statistics that I've managed to draw from the huge amount of services and data sets that I've managed to collect from this project. So I'm going to start by talking about the discovery problem, what I'm trying to solve, but before I do that, I'm going to tell you about the services themselves. A quick refresher, if you will. So I'm talking about the OGC Open Geospatial Consortium services. So you've got Web Map Service, WMS. Hands up if you've used WMS or know you have. Excellent, most of you. Hands up if you found them easy to find. None of you, brilliant. Hopefully I've solved this problem for you, we'll see. We've got web feature services, so raw vector data. Any show of hands? Lots of web feature services. Web map tile service, base map. Yep, I don't even need to ask. It's web coverage service. Anyone? Yep, actually a fair showing of you. It's a very technical and geeky audience, this one. Web coverage service is very poorly represented in this. So web coverage service, raw raster data, really. So those are our standards. In the past, if you've ever tried to find this data, it's been difficult. So this is if you search for, a decade ago when I did my master's degree and I wanted to try and find WMS services, this is what you would find. Today, if you search for WMS servers, this will be the 5th result on Google. Now, for those who are paying attention, that date is not current. If you actually look into the archive, you'll see that actually the data behind this is identical to the data on the same page from 2006. So this is 13-year-old data, and of the 1,000 services on there, only 4 of them work. And 2 of them are the same. Now, Google hasn't managed to figure out that a page with 1,000 bad links on it is a bad result, but that's a question for Ed. So this is what I'm trying to solve. You know, these services are very hard to find. So you might think, why don't we try geoportals? That's a solution. But there are a lot of them. So, I mean, we've heard Shona talk about earlier about the spatial one for Scotland. I think there are a couple of different ones for Scotland. But there's data.gov.uk. Wales has its own as well. Within Scotland, there's also Marine Scotland as well. It's another one. And before you know it, you've got several hundred geospatial portals, be they CCAN portals, CSWs, various other bespoke ones, which are a nightmare to crawl. There's basically a huge amount of these portals. So if I want to find data for Scotland, where do I go? So the idea is to try and aggregate them together. And even if you were to find, say, go to the Inspire portal for Europe, great. 13,000 different services, you can search through them. Half of them belong to one German agency. They're a very profligate agency, is all I can assume. They're very ahead of everyone else. I don't know what they do, but there are a lot of them, and they take a lot of my time to crawl. So there's this huge number of services out there, as you can see, because Geosphere has managed to find 200,000 services. It is 200,000 now. That's slightly outdated data. So all these services are out there, but they're really hard to find because they're in disparate locations. So the idea behind Geosphere is that it's a search engine for these. Basically, it crawls all of those data portals and aggregates their data and then looks at the services to see what are they actually offering. So what it actually does, we search for this. It's a get capabilities document. It's what the service returns and says, this is what I can do. So this one is actually for Marine Scotland's service. That's a pure coincidence because I originally presented this in Italy, so, you know. Yeah, so this one's for Marine Scotland, but they all look something like this. It's XML, it's extremely verbose. None of them look like any of the others, even though they're standardized, so everyone uses different ones. So we scrape all of these, we find all of this data, and then we run it through data cleaning. So there are a lot of different ways you can say there are no fee constraints, it turns out, and there are no access constraints. I think there are about 5 or different ways you can say no. And most of them are in English. So no, none, no fees, and so on and so forth. So we aggregate all that and just convert it into one thing. So that sort of data cleaning is what's going on here. We do some layer deduplication. We extract the location, which I'll explain more in a second. We remove meaningless layers. There will be mini rant time. If you are going to share data, it is pointless to share it if you have no name on that data, no title on that data, no abstract on that data. No one's going to be able to find it. It's like sharing a blank web page and wondering why no one's looking at it. It is meaningless, so they are discarded. There are about 60,000 of them. So lots of people have spent a lot of time and money creating this data, which is now out there. No one can access, unfortunately, because, you know, if it's got a layer name of 1, is it about the number 1? And then we merge the data sets together. So if a data set is available via WMS and it's available via WFS, we consider that one data set for our purposes, if it's coming from the same service. So we kind of glue them together. So when I say distinct services, distinct data sets, I mean it's different. So these are the current-ish, actually are a few months old statistics. Actually, no, they're current. So there are like nearly 1.3 million web map services represented within the Geosphere search index across 130,000 WMSs. We've got web coverages services. There are far fewer of them. There are only about 10% of those compared to web map services. Web map tile services are probably overrepresented because of the way Esri do it. So Esri kind of defaults to having it on. There are a lot of ArcGIS servers serving up these. So that's probably why it's so high. It's really supposed to be a lot lower, or not supposed to be, but generally is lower. Yeah, so there's all this data now in Geosphere, and it's nice and searchable. So in theory, demo time, let's see, here we are. So, we are in Scotland, so let's try searching for sheep, if I can spell. Why not, right? You've got 130 results around the globe for sheep. For Malta, apparently, is the top sheep place to go. You've got some in Lithuania. So you remember earlier where I mentioned location extraction. So location extraction is basically where inside that get capabilities document, each data set is declaring, I cover this area. So what the location extraction behind Geosphere does is it says this area is covering Lithuania, it's covering Malta, it's covering division number 15. That's a census division in Canada, apparently. And so on and so forth. So there's lots of these. Some of them are global. There's actually quite a lot of global. There we are. If you want Barbary sheep globally, you can click on a layer and find out more about it. This is science-based, so in theory it's going to have a nice abstract. In practice, no. So I know almost nothing about this, apart from the fact that it's projected in WGS84. Yeah, they haven't put any abstract down on there. Coverage global, so that's your bounding box, it covers the globe. Alternatively, let's say if we search for Edinburgh, where's the return key? There we are, Edinburgh. So here we're finding data that covers Edinburgh. So things like Spatial Hub Scotland, which is, again, what Shona was talking about. What else do we have? More Spatial Hub Scotland. So there's the National Library of Scotland. Chris is going to talk to you in a minute. And various other data sets that have an extent that covers Edinburgh. or is localized to Edinburgh, because obviously the global ones also cover Edinburgh, but if you wanted global, you wouldn't be searching for Edinburgh. So this is kind of what it does, and basically what you do, you find one you like, yay, reproduce energy. This is your get capabilities URL, and you just copy and paste that into QGIS or GVSig or any of the other open source GISs, because we wouldn't want to use any of the paid for ones. And yeah, so ArcGIS will accept it too. Copy paste it into there, and away you go. And you can use it like that. So back to the presentation. So there's supposed to be, oh, slides being misplaced. Service metadata. So time for a mini rant about metadata. Yeah. Some people don't write much metadata. So this is the service level. Basically, it should be like, this is a service about scientific data, about meteorology and stuff. That's what you usually get. You can see that most people at this service level don't bother with keywords. And on WCS, it's like, what's this metadata? It's not there. Yeah, people just don't bother. It's not necessarily as useful at the service level. Yeah, now we're in statistics. At the dataset level, it's much more useful to have metadata. Unfortunately, curators haven't quite figured this out yet. So again, 50%-ish of services, data sets don't actually have keywords. So we end up with things like this. Now, this isn't quite a meaningless layer, because I can take the space, convert the underscores to spaces, which is what we do in the data cleanup phase, and we can get something vaguely meaningful out of it. But ideally, we've got something more like that. But a lot of services that you can see here just don't do that, and we don't have metadata URLs either. I think that's something Inspire's telling you you're supposed to do. If you actually look at the abstracts people have written, light blue means that basically it's more than 50 characters long. Basically, someone's taken the time to write 10 words of an abstract. No. Except for WCS, to be fair, because it's more sciencey. Usually, if there is an abstract, some of them are very, very, very long. It's just like, let's copy and paste the title for our scientific paper into the abstract, which is what usually you see for science base. We can create histograms. So because I've got this huge wealth of services and data sets, you can start drawing out things like the fact that the United States has by far the most services hosted. The UK is in 5th place. So hosts is separate domains, whereas when you get to the data set level, the UK isn't actually on there. It's at 15 because the UK is very federated. So basically, lots of different hosts, everyone running their own thing, not much data out there. Whereas France and Germany especially are very centralized. We can create plots. So I gave a very similar presentation to this at GISRUC earlier this year. Mapping conference, there were no maps. I felt, let's have a map. So we've got a map. This is basically where those extents cover. I apologize for the color scheme, but this is by far the best color scheme for actually representing where things are. So you can see the nuances. Europe, or specifically the Netherlands, South America's great, or pretty good coverage, South America. The United States, of course, quite a lot as well. Going more into depth in West Europe. So there are some caveats to this, not going into this. You can find these on the Geospatial webpage as well. They list all the caveats because, yeah, good science requires caveats. And like Kenneth last night, actually, I really need to copy that one into it. So you can see, yet again, Belgium and the Netherlands, huge numbers of, like somewhere in the Netherlands, there is an area with 40,000 data sets covering it. It's like the most mapped location in, well, Europe, the world, apparently. The UK is, well, it's there. Let's just say the UK is there. And there's something going on down the south of Spain. So if we look more into the UK, actually it's all happening in Wales. So you can see we've gone from 40,000 down to 2,000, so that's why the UK wasn't actually showing up on the previous map. We're just, colour scheme-wise, not on there. Wales is where it's all happening, and not in Scotland, let's be honest. Sorry. Glasgow actually has a little there. Edinburgh might, but it's under the black. Carlisle is an exciting place. Somewhere in the Cairngorms. But mostly it's kind of south, a little dot for London. London has shrunk, apparently. But this shows basically where people have taken the time to put their data online, and in theory, everywhere should have some data, because Inspire, right? So this is a good representation, and a fun one, of sort of which areas are doing well, or maybe have too many data sets, like Wales, whatever. Yeah, if you configure your server certain ways, yeah, things happen. Yeah, does anyone have any questions? That's me. Thank you. Ian, hello.
How much is your result skewed by, for example, the default data sets that ship in GeoServer that nobody ever takes out?
I have removed default servers. So default servers are not included, along with all the demo servers. So the boundless demo servers are excluded. The Tiger data sets are included. I've done my best to exclude them. So that's in the data cleanup service one. Yeah, good question.
Any work on pulling out license information and actually can I use data as opposed to can I see data?
I could do quite easily. Unfortunately, a lot of that is in German or whatever the native language is. So this is, again, I don't have the resources of Google by about 4 orders of magnitude. And that's just in personnel. For money-wise, it's several more. Strange. All the corporate jet. But what I do have is, basically I've got a list of 200,000 services and 150,000 endpoints, which is what I would consider endpoints, which has your license information. So I have the information. Some of it I can translate because it's in English. The rest of it is in other languages. And again, because a lot of these services aren't necessarily in English first, it's hard to find out. And even where they are there, they're not necessarily correctly representing, because again, a lot of the data that is there is not necessarily correct. Yeah. And services do have a very short, one thing I didn't cover is that data sets have a very short half-life, so there's a very cycling of data. So even if you find data sets and services, they may be gone next time you find them. So even if you do take the time to figure out a license, it may be gone. Any other questions? Do we have time? Oh, Gobi.
Hi, Jonathan. Thanks very much for that presentation. It's really, really good. As you've communicated your results, to different conferences, what has been the reception from, implementers and organizations that deploy those services? Are they doing something about it, or?
So I've had great conversations with Wigan at the front there. I know. So I provide feedback saying this isn't. They ask questions about, is it working? And I look them up, and because I have a copy of the database here, so I can look you up, and if I can't find you, there's a problem. But I can then try and add it to the index. So I'm totally up for it. Some are better. The problem is there are 4,500 hosts, so that's different organizations hosting this. I can't talk to all of them, so if they come to me, totally up for it. The reaction I've had so far has been good, because again, Wigan, it's very responsive. Yeah.
Okay, that's great. Thank you.
Thank you.
No problem. Just before we go on to the next talk, a quick note. If anyone's going along to the Jupyter Notebooks workshop directly after the next talk, just a reminder that there's tea and coffee and cake, I believe, being served actually in the workshop venue. That's the Salisbury suite. So you don't have to go all the way back upstairs to the general tea and coffee. Okay. So next up, we've got Chris. Yep. From the National Library of Scotland. Just find your presentation. Hope you've got more luck than others.
Yeah, my PowerPoint should be there already. I'm not quite sure the folders, where things are. Do you know the folder structure of things? Do you know where the folder? It was certainly on here somewhere where the folders are for today.
It's not that one. It's in this one.
Ah,
Is this it?
there we are. It's not the Friday sessions, it'll be Thursday sessions.
Seems to be the Friday sessions. Shall I open it? No. It seems to be that we've got.
Oh,
There we are.
that was, what were you there? There we are, that's the
This one.
second one there, lovely. Double click on that. Brill, that's lovely, thank you. Thank you. Great, yeah, well, we've heard a lot already about JavaScript libraries and code libraries, but I'm special in working in a real library with real books and real maps. And what I would like to do in my brief slot today is publicize a set of open source viewers, particularly using open layers and tools which can be used to deliver maps online, to explain a little about how our current web mapping technologies in the National Library of Scotland work. And they're really divided into two main groups in terms of what do they do. We've got, first of all, viewers that support search and retrieval. And secondly, those making available historic georeference maps. And all of these viewers and tools that I'll describe have been made available on GitHub with commented code. And just to give a taster, the viewers, amongst other things, allow you to drape Bartholomew 1940s mapping here over a 3D landscape. And while you're enjoying the image, I should say by way of introduction, I've already seen many presentations so far today by people with far greater technical proficiency and expertise than I have. My background is very much as a map curator who's picked up a bit of JavaScript over the last few years. So you won't be hearing from me any cutting-edge open layers technology. But what I hope I can offer is practical implementations of how we've used open layers for delivering historical maps. And so in terms of a brief structure, I'll talk about the map collections very briefly, give a flavor of the kind of maps we're putting online, the website itself, to look a little at the search and retrieval interfaces, georeferenced map interfaces, a bit on the help documentation pages we put together, and then how we combine these tools and functions together in example viewers. So just by way of a brief 1 minute summary of historical mapping in Scotland, the earliest maps that we have were the hand-drawn maps by Timothy Pont 4 centuries ago. These mark the beginning of detailed Scottish cartography, the first man who set out there to record the landscape in detail, and his maps were used to create the first Atlas of Scotland, published by Johann Blau in 1654. We've got maps relating to the largest Scottish towns, mapped from the same sort of time, the 16th century onwards. And there are important military map collections too, particularly associated with the Jacobite risings in the 18th century. We hold things like estate maps, charting things like landscape improvement and clearance. Important special collections, such as those of the Stevenson civil engineering firm. And a small collection of air photographs too. Ordnance Survey mapped Britain from the early 19th century, Scotland from the 1840s onwards. And these are by far the largest and most heavily consulted of all our online collections. hugely valuable for allowing detailed chronologies of landscape change to be viewed through successive editions. Now, Scotland has been the main focus of our work and our collections, but we do have extensive physical overseas collections. And in the last few years, we've added various of these overseas collections online with things like trench mapping, maps of Cyprus, Jamaica, and the Blau Atlas Major of the whole world. And putting online our physical collection has been my main job for the last 2 decades. We now have 220,000 maps online, which sounds a lot at first, but it is only about 15% of the collection. We tried very actively to georeference the 19th and 20th century maps, recognizing the great value of georeference maps. And we've got quite an active digitization program. The aim by 2025 is to have 1/3 of our collection available online, around about 600,000 maps. So things should significantly grow over the next few years. And the website has grown in usage as well. Every day we have around 9,000 user sessions and around 30 to 40,000 page views. And in terms of our long history of putting stuff online, like many collections, we tended to add things online in sensible enough ways at the time, but looking really very limited in terms of what we now can do. As more collections were added, we tended to give them new links, and our growing list of bullet points on our homepage became steadily longer and longer. And at the same time, 15 years ago, we tinkered a little with Esri ArcIMS using bounding boxes before extending the bounding box approach for all of our online maps in 2012, and at that time moving completely to use open source software for our main viewers, OpenLayers and GeoServer. And I was given a push start on these viewers by Clocken Technologies when we set things up, with whom we've collaborated on various fronts. But since then, we've been forced to develop much of the viewers themselves, very much in-house. So what does this mean in practice? Well, in practice, you can still browse map categories by written lists, like things like ordered lists of different types of maps by MapMaker. But the main way of finding everything is through what we call, at the moment, our Find by Place portal. And this allows you to zoom in on any place of interest. This is essentially an OpenLayers application. The bounding boxes are coming from GeoServer. You can click on your place of interest. The maps that cover that appear down on this right-hand side, and then you can click on any of those to view the map itself. This is a JPEG 2000 image delivered through IIIF server, and it allows you to quickly zoom in and pan around, and then you can go back to the Find by Place viewer, choose another category of mapping. Different bounding boxes appear for 25-inch to the mile map. It's the same process of clicking on the same area of interest, and then on this side appear to view the individual map itself. One of our challenges is a very broad spectrum of users and their different competencies. And so one of the other viewers that we've also developed more recently allows a simple marker to be placed on any point, and all the maps that cover that point appear on the right-hand side. And it does away with the bounding boxes and allows you to also filter things by date range and by other criteria as well. So that's the Find by Place viewers. The georeferenced viewers are by far the most popular area of our website, allowing all the things that you would expect. So we're looking here at ordnance survey mapping from a century ago for where we are here today, and you can slide the transparency to fade the historic map to reveal whatever modern satellite or map layers you want to see. You can also compare the historic with the present day, swipe as well as the side-by-side viewer, and also compare different dates showing how the attractive meadows that were here in the 1850s were replaced by a gasometer and an industrial brewery by the 1870s. You can also combine the georeferenced layers with elevation data using the open layer cesium connectivity, and present maps in a whole range of fun ways, such as through the spyglass viewer. So I'll say a bit more now about the software. We use a mixture of open source and proprietary tools. Open source particularly for the main public interfaces and some desktop processing. But we also use proprietary software too, MapTiler for preparing geotiffs for the web and Geographic Imager, SQL Server, which is still the National Library's default database, and IIIS Server delivering our zoomable images. But all of our viewers are based on open layers, and I would say many of the functions that we employ are taken directly from open layers and the wide range of tools and functionality it has, and the examples as well. So how do you use our viewers? They are available on GitHub as individual repositories with notes. A few years ago, I wrote a brief blog that outlines the main viewers we then had. And earlier this year, if you're really interested, there is a paper, an online paper in ePerimetron that describes all of the viewers in detail. A year ago, I was also invited to New Zealand to give a workshop on using open layers to put historic maps online. And so for that, prepared a suite of different viewers with quite good documentation and guidance that's all available as well. And I would say this is very much pitched to beginners. It's not pitched to the more experienced developers at all. Just to run through some of the viewers in a bit more detail, some of the things that we've been recently working on have been better ways of visualizing the bounding box information. This comes back from GeoServer through a web feature service, and ways of connecting this to specific maps through jQuery. Being able to visualize the extents of a particular map when hovering it over in the Find by Place marker viewer. Many of the tools that we've developed have been driven very much by our user community writing in saying, how about doing this? How about doing that? And a lot of them take and slightly adapt existing open layers functionality. One of the things we were pleased to add earlier this year, again through a tip-off, was LiDAR data from the Environment Agency that provides a very nice way through the transparency viewer of visualizing some of the subtle relief in connection with historic maps. Another request we had was to add a marker function to the Explore Georeference Maps viewer with a permalink, as well as an ability to click on the map and bring back coordinates information, national grid information for copying and pasting. And so these sorts of tools within our capables, as you'll appreciate, they're not very sophisticated, but they're all there and available. And the 3D viewer really adapts the OL cesium integration, allowing vertical exaggeration to be dynamically controlled through a slider, and therefore bringing out the mountains as necessary. So I'll finish off just to run through a few of our collaborative applications. These mix and match a lot of the existing functionality and have been very much driven by people coming to us with ideas for visualizing data. The Scots-Italian map viewer from about 4 years ago was an exhibition at the National Records of Scotland based on a detailed census done of Italians living in Scotland in the 1930s. Another collaboration with Historic Environment Scotland was to compare the historic land use maps that we have for the 1930s with their present-day historic land assessment layer. Another viewer was creating a search interface to the travels of a Scots diplomat who went to the United States in the 1790s and wanting to visualize the routes that he and his wife took on a modern map as well as on a contemporary historic map. A viewer last year commemorating the centenary of Frederick Douglass, the African-American anti-slavery campaigner, his visit to Edinburgh, and subsequent visits again to Scotland. A viewer earlier this year that makes available a small selection of maps of Stornoway that belong to Western Isles Council. They were keen for them to appear in their own bespoke viewer as georeference layers, and so it has some of the functionality stripped down into a bespoke kind of container. And a viewer from just a couple of months ago that is a research project at the moment trying to map the extents of the Stevenson civil engineering plans that we have. And some of these use GeoJSON, creating more dynamic interfaces, others through the volume of data that we have, bring back the data from GeoServer. So, just to wrap things up, I would say they're all very much work in progress. All these viewer interfaces will all change very fast. Fortunately, I feel with open source and the rapid developments, ongoing developments supported by a wide community, it's very easy to keep up to date by linking in with that. But these are just one way amongst many others of making maps available. And I hope that some of what we've done may potentially be useful or adaptable by the broader community. Thank you very much.
That was really interesting. Good. As a cartographer, I definitely appreciate it. I think we've maybe got time for one quick question before we all head off for tea and coffee. Anyone? Down here.
So, how you digitize paper maps into a nice geo-referenced sort of thing. Do you have any sort of documentational stuff on that?
That could be another hour presentation, I think. Yeah. Maybe we could chat afterwards, because, yeah, we've used a lot of different technologies, and actually there are quite good open source tools we use with QGIS for very rapid georeferencing of maps based on shapefiles that we have of series maps. But yeah, I think that I could perhaps talk to you more easily rather than to a whole audience.
It's another conversation. Okay, I'd just like to thank all the speakers this afternoon. Really interesting and varied topics. So thank you again. If you would like to join me in thank you. So time for tea and coffee and cake, I think. Just a reminder about that coffee in the Jupyter notebook session.
Good afternoon. Welcome to the next slot, which is the Unconference and Lightning Talks. We've got a number of speakers who are going to speak for up to 5 minutes on their preferred topic. The first person is going to be Kostas Sidoris.
Let's have a go. That looks like just as it is the mic. Which side's it on? This side, yeah. Let's pop you up on here. Yeah. That's about it.
So, nothing. Hello, my name is Kostas Sidoris, and I work for the Joint National Conservation Committee, JNCC for short. And if someone of you have seen part of my talk this morning and someone didn't, so I was interested to just show part of our team what work is been doing the last few months. So we were involved in a project with Scottish Crop Map, and we were asked to do the segmentation part of it, and I was asked to do it. And it was my first time actually being involved in segmentation. Didn't know what it was. So it was like a learning opportunity for me. So for further step to that, our team started testing like different segmentation methods to see what's out there, what's best used, and what we can do. So this kind of talk is actually even like for you guys, just to help us with ideas, because sometimes we get stuck and you come to this. It's a great opportunity to learn and get new ideas. So we just basically here what segmentation is like you just take an image and take out the elements you want to analyze, and it's really important to us because it can, you can analyze individually parts of an image, and you can really very easily put it into the next step of process or anything else. So it's a kind of really interesting area. So for my test, we used 3 different softwares and algorithms out there, and we were really focused on something that is open source, so it's available to everyone, and we just compare it to something that is not open source. And we compared the Orfeo toolbox and its segmentation algorithm, GraphJS and its recent updated segmentation algorithm, and of course a lot of you know Recognition segmentation. And we used the same input, which is like something like really simple. We didn't go too much into detail because we want to test it for people that don't know too much about segmentation, just to do it like out of the box and see what results we get. So we use like a 10-band Sentinel-2 imagery for all the 3 algorithms. And the good thing with Orfeo and GraphJS is they have the same kind of you can say you have the same tricks in the algorithm, so you can set the same parameters. But that's not possible in Cognition. Have like a really different approach, and we're currently trying to find out something so we can compare it and get the same results. And for the results, we have some pros and cons. The Orfeo toolbox is really good. It's very detailed segmentation, flexible with, you can have a lot of adjustments in then to produce the required result. And it has difficulty with copying large data sets, so if you've got a really, really big mosaic, you have to have a really powerful machine to do it. GraphJS is basically the same. Doesn't have any problems with the stitching as the Orfeo toolbox, and the only drawback maybe is that it's only in raster format results. And then in Cognition, really good. Everybody knows it's out of the box. You can put it in without any tricks in the algorithm and produce a really good result. And here you can see all of them, and you can compare them, and you can see that they have some differences between them, but they have really good results. But the thing we have trying to see is there a way to avoid the sticks and issues? We have the Orfeo toolbox in some of the bands you input. They have they don't do really good. The polygons are having some, really straight lines that are not representative with the ground truth. And also we're looking at a process that will produce an algorithm probably that you can put different segmentation needs from different sources and tells you you know, is there a way of comparing which is best and which does the best work? So, yeah, that's it. Any questions?
We should have said, I think we'll not do questions, because that's
Yeah.
5 minutes, 4 minutes.
Okay.
Next, we have Kathy Jin. Thanks very much.
Okay, so my name's Kathy. I'm also from JNCC, and I'm going to talk about some of the mapping work that we've been doing in South America. So what you can see on the screen here is satellite imagery of Colchagua Valley in central Chile, which is our area of interest because it's famous for its wine production. There are a lot of vineyards, and it's also a biome which has a lot of native species, so it's a priority for conservation. So on the one hand, you have farmers who want to kind of expand their businesses and urbanize, and on the other, you're wanting to protect these different habitats and the ecosystem services that they provide. So what can you do to help? Well, you can create mappers like these, which make environmental data available in a way that the farmers can use in their decision-making processes. So the idea is they can come on here and they can look at the different data that they can use to base their decisions and hopefully make more sustainable decisions. So our ecosystem services team completed a project in this area. They talked to a lot of farmers and they gathered data. They did a lot of analysis and modeling with that data, and they created these maps offline at first in QGIS, and that was all kind of done and dusted. They wrote a report, and then we helped them to make those maps available in an interactive way on a website, which is what you see now. So technically, what is this? This is using, as you can see, Leaflet.js. It's running as a single-page app, which is bundled up by Parcel.js, and is hosted on GitHub Pages. So by using that, it's free. There's no management of servers for us, so it's a win for it, basically. So the data itself, we've put into GeoServer. So we took their QGIS layers and we put them in this GeoServer, and we're hosting that in AWS in an EC2 instance. And yeah, it's a fairly simple map which we've knocked up fairly quickly, but it just helps to make this kind of data available to these farmers. It's really available. You can go to it yourself if you want, on the URL, and hopefully it will help them to make better, more sustainable decisions, which will help everyone, really. So next steps. The Chile mapping work is kind of coming to a close. It's going to be featured in Nature News, I've been told. And next on our list is Colombia. So apparently there are banana farmers there. So we're going to be doing something very similar to what we've done here. So there'll be data layers very similar to this, and also we're taking it a few steps further by making it easier for users to see data in a certain area. So we'll add functionality to let them click on an area and see all the data for that area, rather than having to click through all the layers. And we're also looking into using tile caching, because we don't need GeoServer. None of our requests are very complicated. We're just pulling the data out. And so if we use a tile cache in something like S3, then it should make this quicker to load. The data should load quicker. It should be cheaper to run, so it should really be pennies to run that. And hopefully it should make it more reliable as well, because GeoServer we found is a little bit flaky. So that's pretty much it. You can find more information by just going to this URL, clicking through some of the links in the info page, or searching JNCC Chili Mapper. We're here as well, both today and tomorrow. And also, if you have any experience on tile caching, then let us know, because we'd like to hear about your experiences. So, yeah, that's it. Thanks.
Next, we have Barend Coben.
Where is my... Oh, somebody closed that. Not used to desktop, sorry. Somebody closed it, but that's it. Okay, so my name is Barend Coben. I'm from the Netherlands, ITC, University of Twente. And I want to talk about two things that I find interesting and exciting, namely teaching cartography, mapping, data visualization on the one hand, and formal languages for doing so, or parameterized mapping, or whatever you want to call that, on the other hand. So this is officially called an open educational resource using Vega Lite. Oh, I should, wait, where's this one? Sorry. Not my computer. Control F, I guess. Where's the... Oh boy. Okay, do it like that. Sorry. The page view, right. That's the one I need. How can I put this on rule? So, those of you who know cartography, mapping, know that there's such a thing as a cartographic grammar that a French guy made up quite some time ago. And the nice thing is that these are rules for effective cartographic communication, and they are written in a way that humans can understand them, which is nice and interesting, but not all that useful. So later on, of course, people continue that kind of work. One example being the Grammar of Graphics of Wilkinson, where he made it formal, this grammar, so that it could be implemented in computers. So that's interesting if you are interested in computerized mapping, parameterized mapping. Then you can build visualization pipelines. So visualization pipelines basically are any kind of pipeline where you put in data on the one hand and a nice map or graphic comes out at the other end. You have loads of them, different low-level or high-level ones, procedural or declarative, and the ones I'm interested in, and the one that is useful or usable nowadays because of technologies such as Vega Lite, is ones that are high level and declarative. So you can declare the output that you want. You want a certain type of graph, a certain type of map. You put in your data and it should come out of the other end. Vega Lite is a grammar or a format, whatever you want to call it, a language that works like that. So this is a Vega Lite definition. It's made in JSON. And so you say there's some data is inputted. The data should be shown as a mark, which is of type bar, and then it should be encoded in a way that the X should be coming from one of the fields of the data being ordinal, and the other one, the Y should be another data in a quantitative way. And what you get out if you run this is a bar graph with all the fluffy bits like the axes and all the things being made by the system itself. They are, let's say, standardized. You can override those standards, but this is what you get. This is actually made by the same people, thank you, that made D3. And you can use it in a web environment. And so we thought, well, if we have this graphic grammar that we want to teach our students, where you have to actually teach the students to make these decisions, you can actually parameterize this and make a small web application that actually does this online. Where is it gone? Oh, no, the other one. Where is... Oh, there. So people can actually load any data that they want. For example, some data about the number of cars in municipalities, and they can decide, well, I think this is quantitative data of an interval type, and so we can map it as value or as size or as texture.
And this way the students can actually try all these different ways out of doing this. They can find out hopefully that some of them are better than others, they communicate better, and they can actually you can actually teach them the proper way to do this. But the interesting thing for me is that this is built using just a simple template which can be used over and over again because it's parameterized Vega Light. So the Vega Light for this particular map is like this. You get some data and it's coming from a template, so whatever data you put in should work there. It's in this case a map, and it encodes the color as an ordinal type. And if you change any of these settings here, it changes the color from or it changes to a template, which makes it, instead of ordinal, it makes it ratio data, so absolute data. So in this way you can have a pipeline that you can, in principle, put any data in and it always would render a map. It's not always a good map, and that's why what the people will use to be taught how this works. Thank you.
Thanks very much. Can we now have Matthew West?
Oh, goodness. Do not pay any attention to the label of the file. Page. Oh, goodness. All right. Okay. So, so this is specifically actually inspired by Alistair Ray's maps that he made a number of years ago regarding commuter traffic. My particular research was on, for my master's thesis, was on spatial regression, and this is the way that I use to define closeness in spatial boundaries. Can I go down? Okay, I will just use this. So just to give you a little context for what it is, using Bayesian car models to investigate the socioeconomic forces underlying the results of recent contentious UK popular referendum at the local authority district level. I need not speak anymore. The standard operating procedure for defining closeness is usually by border contiguity. Basically, do two districts right next to each other. The problems with this are borders are often drawn to mirror physical barriers, mountains, rivers, etc., and modern transit allows you to cross these or go around them. So things that are close might actually not be connected much at all, and vice versa. Things that are nominally not close might be really, really close because subways exist. I have an alternative proposal using the commuter rates from the 2011 census to see how much people travel back and forth between districts. The math, not really necessary, but the percentage of residents in one district that work in another, or the percentage of people that work in a district that live in another. They're not the same thing, I promise you. It's for increased wise, you can employ symmetry and also normalization to binary weights if you want to sort of have it as close to standard operating procedure as you normally do. And it's for most analyses. And because we only have a few minutes, and sadly I was only able to do England in the context of my work, here are the links between all of the spatially related districts in England. You naturally see the big London metro area, unsurprisingly. You also see Birmingham and the sort of greater Manchester Liverpool area, plus a bunch of the notable hubs in various places. Also, you can see the Pennines and the Yorkshire Dales, where basically no one much crosses those boundaries. Surprising to anyone who lives in the north, probably not. So is that there are 326 districts here. The lines are cut off at a 0.15%,
and is that you basically use those in your regression model to define these sort of mixed random effects portions of your regression. And thank you. The list of the particular packages, my references, and any questions if we have time, and please do not think about the event. That is it. Did I have a moment, or we just keep moving on?
Well, we're just going to keep moving on, yeah.
Well,
they can
find me if you have any questions.
They can question you later. Yeah. Okay, so next we have Rob Coop.
Of course, it's on the other side. Cool. Let's get that one over there. Hang on. Why is it always the other way? Cool. Okay, I've blatantly stripped down Evan's talk from Bucharest here, so find the video if you want to learn more, or ask me. Coordinate systems in the open source GIS world have always lived in a horrible mess of CSV files. And different bits of software relied on different bits, all coming from different places, and there are approximately 2 people in the entire world who could make it work. Now, converting coordinates. This one is easy. You're going from UTM to trusty old 4326. This is an exact operation, and you'll get about nanometer accuracy. This is what Proj has done for like 30 years. But it gets a bit more tricky if you go somewhere else. So we go to New Zealand and we look at the old datum and the new datum. And in this case, there is no mathematically perfect way of converting them. The EPSG data provides 2 transformations, one using a grid and another using a formula. Unfortunately, Proj couldn't actually use either of these directly because everything has to go through WGS84 in the middle. And all these conversions, the inaccuracies combine. So it could be 20 centimeters, but having to go through WGS84 means it's more like 1 to 2 meters inaccurate. In this particular case, the New Zealand datum, and in some other cases, is basically WGS84 anyway in the second case, so it kind of works out. But if you go to Japan, after the quake, the land had moved and the Japanese created a new datum. But there is no conversion from WGS84, and Proj could never use the direct transform. So you end up like meters out. This is no good. And good old Australia. The old datum was 94, the new one is 2020. And Australia is diligently trying to become part of the Northern Hemisphere at like 7 centimeters a year. So in the last 25 years, it's moved 2 meters north. And if you convert from WGS84, it's actually a no-op each way, so the coordinates end up wrong. And this is actually because WGS84 has changed definition. And if your reaction to this is, what? Like mine was a month ago, then talk to me later. But again, the direct transform from the old one to the new one, Proj couldn't really use. So we end up with like about 3 meters out instead of about 1 centimeter. So CRS management in the open source geospatial space needed a lot of work. And Evan and Howard Butler hustled to pull together some funding, dubbed the GDAL barn raising. Proj 6 came out in March. All the WKT handling, which used to be in GDAL, is now part of Proj, and it now supports WK2, which handles vertical things, and time, and dynamic coordinate systems, and all sorts of other cool geodesy stuff that nobody cares about. GDAL not supporting WKT2 was the main reason nobody at all supported it. And my understanding is Esri built it years ago into ArcGIS, but never turned it on because GDAL would be incompatible with it, because the entire GIS industry depends on GDAL. And the various text files that we talked about, all those CSV janky bits that GDAL, Proj, PostGIS, and all these other bits use, have now been replaced with one SQLite 3 database. It's faster, it's much more detailed, and it's sane. And now we can use the best available transform, what Evans called late binding, So those things that didn't work before, like Australia and Japan, now work properly. We'll use the most accurate conversion between two datums that we can, which means that our answers will be more accurate. And those errors aren't accumulating. There's a new command which tells you exactly what's going to happen and how your coordinate conversions are going to run. It's called proj.info. And you can use that to make sure what the different options are and how your kind of conversion pipelines are going to work. What you need to do, though, is stop using proj strings for CRS. So if you look at those proj long lat, blah, 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 don't do that. It could be any of those coordinate systems lying underneath it. And so what you want to do is use the EPSG codes, and it will use the right thing. GL3 came out in March as well, and the major change between 2 and 3 was this project stuff. And it also honors the axis order stuff that it hasn't really for ages. But it does do a whole lot of magic, so all your existing stuff that assumes everything is XY will not be broken. The latest QGIS and PostGIS and GRASS are now using projects, and my understanding is that R and others are working on adopting it as well. Thanks to all these people who contributed lots and lots of money to make it all happen. And that's the end.
Next, can we have, I'll have a go, Goba Hobona. Thank you, sir.
Okay, just going to download, sorry? Oh, yeah, I need to download something first, just one second.
You can put it in when you're ready.
All right, okay. One second.
I'm just the man who holds the plug.
Okay. I realize I'm chowing into my
Gotta get up for
go back. 29. All right. I think we'll have to do it with our slides. Oh, wait, no, here it is, here it is.
Can I?
Yes, please. Yes, please. Okay. Awesome. Okay, so I'm going to talk to you about a series of standards that the OGC is hi, my name is Gobe Obon, I work for the OGC. So I'm going to talk to you about a series of standards that the OGC is currently developing. They are based around web APIs, and we recently had an event to advance that development. First of all, the OGC APIs are really they're designed to provide a web API based interface for what historically have been traditional OGC web services such as WFS or web feature services, web processing services, and so on. On this slide, what you can see are the specifications that we are currently focusing on. The OGC API for features, formerly known as WFS3, it was recently approved by the technical committee, so you should be seeing that on the OGC website within a few weeks. However, at the same time, we're working on specifications for processes, map tiles, coverages, and also catalogs. All this work has been done on public repositories on GitHub, so anyone can have a look and contribute some of their thoughts. So recently in June, the Geospatial Hub hosted a hackathon, an OGC API hackathon. We had 70, or just over 70 participants literally from across the globe. And we built an architecture kind of like this. We had several implementations of each one of those specifications. And within that 2-day hackathon, the participants were able to integrate their components. You probably won't be able to see this at the back, but what the key point behind this slide is to show that we had a good mix of both proprietary and open source projects represented. There was Rastaman, EUX Server,
GeoServer, PyGeo API, several other open source GIS initiatives represented. And they were all able to integrate their components to demonstrate and also to identify any flaws or any issues with those specifications that needed to be addressed. So the key findings of that hackathon were that the OGC APIs, even though they're still in draft form, they are actually implementable. And the approach as well that we've adopted, which is that of building blocks, that approach enables developers to be able to build or to integrate those APIs into the APIs that you're already developing using Swagger or OpenAPI and similar frameworks. But also, the hackathon also proved that the combination of HTTP, HTML, JSON, as well as other web-focused approaches, it actually leads to viable solutions. So that that was really good to see. So, in terms of conclusions from the hackathon, was able to develop, deploy, and test the draft OGC APIs, as well as provide, the community, not just OGC members, but also non-members, and to provide them an opportunity to provide that feedback and also integrate some of that knowledge into the actual specifications. But we're also able to, to develop rules and guidance for how those APIs should be implemented. And of course, it provided an opportunity for the community to basically take part in the OGC standardization process. So I'd encourage you to have a look on the GitHub, OGC GitHub site. You'll find all of the resources, links to all of the standards that we are currently developing, as well as reference implementations that are being developed across the community. So thanks for your time.
Okay, now we have Pirit Ulm.
Hello. I don't have anything to put up there, so it's just me. I wanted to do a quick intro to our organization, Satellite Applications Catapult. We're a unique innovation and technology company which boosts UK productivity by helping organizations harness the power of satellite-based services. We work with businesses of all sizes to help them grow by tackling barriers to innovation and accelerating products and services to market. By connecting industry and academia, we get new research into the market more quickly and bring together multidisciplinary teams to generate ideas and solutions in an open innovation environment. We are one of many of catapults established to transform the UK's capability for innovation in high growth areas for the UK economy. So if you have a great project or idea, or your organization works with satellite technology and satellite data, and you want to talk about some of the ideas and how you could work in collaboration with the catapult, come find myself. But more importantly, if you happen to be a SaaS specialist, a geospatial software developer, or a solutions architect, we've got loads of career opportunities. We'll be really keen to talk to you as well. Thank you.
Thanks very much. Can we have Ian Turton now, please?
Not a problem. Go away, Windows. See? Told you there was no problem. I think you've never seen an HTML file before, actually. Close enough. Right. This is a bit of a rant rather than a publicity thing for anybody. Start by saying that this isn't any way related to my boss's views or my work views, just in case Mike's watching the live stream. So this is a short cut-down version of the talk I gave in Bucharest with Andrea Emi at FOSS4GUK, which for some reason has gone viral today on Twitter. I don't know why. This is how everybody thinks open source projects run. And the tappy top slides, lots of people happily working together. Actually, that's more like how it works. It's 2 or 3 of us sitting in a basement or in our front rooms with our wives sticking their head around the door saying, "Come on, dear, why aren't you coming to bed? That looks just like work. You told me you were off to do something fun this evening." I'm going to ask a quick question. How many people in the room have used open source software? Excellent. How many people in the room have contributed to open source software? That's third, maybe. How many people know that their employer has saved an enormous amount of money by switching to open source software? Half probably. How many of you contributed any of those savings back to the projects you're relying on? 6. How many would be in terrible trouble if, for example, we stopped releasing GeoServer next month? No, you wouldn't. None of you would be in trouble because you've got the software. You can keep it. But you wouldn't get any more updates. So this leads us on to one of Andrea's favourite slides, which is pretty much how we've just did. Who wants well-maintained open source? You know, who actually wants to contribute some fixes? And who wants to step up and help us write those fixes and add them in? It all goes very quiet at that point. So I'd like to encourage you all to think about becoming contributors as to an open source project. And I don't mean you need to step up and write code for us. You can do all sorts of other things to help contribute to your project, to your favorite open source project. Who's on the mailing list for the open source software they use? It's not a lot still. If you're a regular user of a piece of software, if you join the user list, you can help other people by answering their questions. Tell them the things that you discovered last year. You can save them a lot of time. It'll make their lives much easier. And that's one less email that I have to answer as a maintainer, and I can spend the evening writing some code, which is actually the bit I enjoy. So, open source has particularly ineffective persuasion, I'm afraid. In that it doesn't matter, you know, just saying, well, we're not going to make any more releases because you guys don't bother testing them beforehand. Well, actually, it doesn't hurt anybody because that's what happens at the moment. We just make releases that nobody bothers to test. As, you know, we run a few basic tests before we release GeoServer, but you come back to us and say, oh, but it doesn't work with SQL Server version X on my Red Hat Linux such and such using Glassfish, and we go, what do we care? We offered you a release candidate 6 weeks ago, and you didn't tell us it didn't work. So testing, contributing to the user list, answering questions on Stack Overflow. There are all sorts of things you can do. You can fix spelling mistakes in the user documentation. I recently fixed 7,500 spelling mistakes in the GeoTools user guide. But we're trying to build up the energy to go into the GeoServer user guide now. You wouldn't think that at least 3 of our developers who wrote those docs are actually native English speakers. It's absolutely terrible. Please, feel free to help out and contribute to your favorite open source software.
In the spirit of that, just to make sure everybody's aware, I believe there are still places available in Nick Behrman's workshop tomorrow, which will introduce you to how to contribute to the QGIS documentation. But those skills would, you know, help you with contributing to documentation for any open source project.
No, it's your turn. It's your turn.
And the last speaker for today? Yeah. That'll be Matt Walker.
Hello everybody. Let's get set up. So I'm that prepared that I'm just going to Google it, okay? Okay, hello. So we heard earlier about the OGC hackathon and the work that's going into a whole host of new OGC web services. I thought I'd just spend a few minutes just raising awareness really of a particular implementation of some server-side software that provides support for some of those emerging standards. So this is a relatively new project called PyGeo API. It's being developed by a host of people that have been involved in the geospatial community and with OSGeo for a number of years, and is under the PyGeo organization. It's currently a community project, which is part of OSGeo. And it's one that I've been keeping a close eye on and doing some testing and the likes of, and thought it was worth a mention. There was a talk at FOSS4GUK 2019, the main international conference, by one of the maintainers. I don't think there's anyone here today that's on the core team. If there is, then hello, and I'd like to have a chat later. But I thought I'd come as a cheerleader and just tell people about the project. So the standards that we're particularly interested with here are the core standards that the OGC are looking to push, which really look to make accessing geospatial data on the web very much go along with the grain of other web technologies. So that means that instead of having a WFS server to access features, for instance, which was very heavily XML based and relied on query string parameters to specify what it is you wanted to get out of the service, we're now moving towards a model where a feature service, for instance, would be implemented as a REST API, which is a common, well-known industry standard for defining access to particular entities, in this case, features. And the status codes you get back for errors, for things that are not found, for successful responses, all work just like they should for web services using HTTP status codes. And you generally get a sane, easily crawlable, easily discoverable way of accessing geospatial data. And that's one of the key things that PyGeo API has implemented up to this point. So the project is available here. There's a very technical section at the start to tell you how to install the thing, but we'll skip that bit. And actually have a look at one of the demos. So number of demo servers available. This top one is based off the current development branch. And hopefully it'll just give you a feel for what the API would actually look like in practice. So we have a landing page which basically gives us a list of all those things that are available as part of the API. And if we jump straight into collections, think of collections as collections of features or a layer, as you might commonly think in say GeoServer or another WFS. Choose one of those. Here we've got a page that's rendered as just regular HTML, very easily indexable by Google or any other search engine, and is available both as HTML and machine-readable formats such as JSON. If I pop into one of these collections, I can see some additional information about that individual collection, and then, perhaps more importantly, can then drill down to view the whole feature collection, which I can then get as a GeoJSON feature collection if I wished, or this HTML view to allow me to page through. So the whole idea is basically taking your geospatial data, being able to publish it on the web in a way that other web applications and web standards have been doing for years, and really bringing OGC up to the modern day. Thank you very much.
Right, we'd like to thank all of our speakers for the Unconference and Lightning Talks. There will be another list on the registration desk for people to sign up for tomorrow. There'll be another slot where you can have 5 minutes of your fame if you want and talk to us all. I'll now hand over to Ross, who will introduce our afternoon keynote.
Hopefully we will, let's stand here. Hopefully the people upstairs will be coming down to help fill the room. But it's great to have Denise McKenzie here to come and talk to us about data and standards and all sorts of stuff. Let's see what she has to talk about. We'll have a minute or two, I think, while we wait for folk to come down. Do you need to?
I was going to say, if we can get the presentation up. Are we right to start? Okay, so, you know, Ross is entirely forgiven there for going, Denise is going to talk about data and standards, because ordinarily, those of you that know me, that's exactly what I would be up here talking about. But the news is I'm not working for OGC anymore, so gone are the days that you're going to hear an open standards presentation from me, so I'm grateful that Gobe was up there covering that one just before. So for those of you that don't know me, I'm Denise McKenzie, also known on the Twitterverse as being Spatial Red. I have worked in OGC for 7 years. I've worked in the industry now for 20 or so years. So I did 12 years down in Australia and working in those sorts of spaces there. What I'm doing now is consulting. And what I hope to do in the next half an hour is just give you a bit of a taste of some of the things that I'm getting involved with at the moment and trends and issues that I think that are coming for the industry that are probably worth you paying a bit of attention to at the moment. So trends. Why on earth do we spend so much time talking about trends? You see things about this all the time, and with Geospatial, there's trends things all over the place. Mostly we look at trends because they're disruptive. We're looking for those things that are coming through that are new, that are going to cause some sort of disruption to the way we do business. And we're trying to work out how much disruption, whether it's going to be good disruption, whether it's going to be really bad disruption. And if it's going to be bad or if it's going to be good, we want to work out a strategy to understand why and how we're going to work with those trends. And at the moment, we are completely rich with resources for doing this. So if you haven't looked at these documents, I would highly recommend. On the side over here, you've got the Geospatial Commission's latest Future Technologies Review. Geospatial Media are doing ones every year now in terms of readiness indexes. Location-Based Marketing Association, maybe one you don't know very well, so I'm on their Global Advisory Board, and this is a global report on marketing trends and the use of location-based information that was released this year. And UN GGIM now is in its third iteration of the 5 to 10 year trends document that it puts out as well. And I would be entirely remiss if I didn't acknowledge OGC's also technology trends work that's here too. And that's a free and open resource. So I popped the GitHub repo up there in the bottom. Really worthwhile having a look at. And I know if you've got interest in this one, do go and have a chat with Gobe about it. He's always looking for more contributions and more assistance with putting that one together. And a bit of a shameless plug up there, if you're interested in the data science side of trends there, then there's an event happening later this year. And I don't know if Ed Parsons is in the room, but he's the host of that one, so go and find him and have a chat. But this is not the trends that I want to talk about today. So again, not going to do techie. I figured you guys have spent a lot of time talking technical all day today. What I want to talk a bit about is what I would term social and policy trends that are coming, that are probably going to have a bit of disruptive behaviour in what we're doing, but hopefully will actually make us a much richer and better industry to work within. So the first one I want to touch on is ethics. Now, how many of you have started looking into any ethical areas within your organisation and the work that you're doing at the moment? Anybody? Bits and pieces? So I first kind of got my head into this space of looking at ethics when earlier this year I got a late call the day before a conference that I was only attending as a participant, and someone said, hey, could you run a session for me tomorrow It's all on insurance and use of IoT and insurance. And I was like, yeah, sure, that'll be fine. And so we ran an open forum session where we were looking at IoT. And during that discussion, we really got heavily into this concept of talking about innovation, the amount of technology change that we've got going on. But how do you define that boundary in the innovation where something goes from being really awesomely cool into being really, really creepy? And in the insurance space, when we started talking about this, we got into discussions about having sensors in your house, sharing that information perhaps with your health insurance so that they knew what was going on, perhaps sharing it with your building insurance people, your home and contents people to look at what you were doing. What was quite interesting from a cultural perspective was when I said to people, hey, well, how would you feel about sharing that information about yourself if it reduced your premiums? And put the hands up. Most people kind of said, yeah, actually, if that was going to make my insurance cheaper, that would be fine. And I said, okay, well, how about if the same data had to be also shared that was about your children in order to get that? Would you be okay then? And only about a third of the hands went back up at that point. So it was quite interesting, and this is the sort of quagmire we've got. Same set of sensors, same type of data, but being collected about different people. And so the ethics of collecting different types of data depending on the person becomes quite a challenging type of space. Anybody have seen this come up earlier this year, ethical geo? I see one hand over here. I wanted to highlight this one because this is a bit of a movement that's happening around the world, and I will talk a little bit more about what's coming here in the UK. You'll get a slight sneak peek of what's coming shortly. Ethical Geo is a program of work that's being backed with the American Geographical Society, which is looking to develop tools and methodologies that will allow us to get better at understanding the ethical aspects of how we're using data, and specifically geospatial data. If you have time, I would highly recommend you get on this website and have a look at some of these videos of the work that people are doing globally that is actually looking into this. There's examples there of data that's being collected in the Amazon and how it's exposing where fires are taking place that were originally being thought to be wildfires but are actually being deliberately lit in order to be able to destroy habitable land so that people can take it over. So there's a quite fascinating array of these things here that you can become involved with. And the sneak peek, and I got permission only yesterday that I was actually allowed to say that this is going to be happening. So don't even bother checking on the web yet because there's nothing there to see. But I mention this now because Geovation is about to launch a campaign of work that is around ethical geo sort of spaces, and we will need your help. There will be a series of lectures for you to be involved with, discussions to be involved with. There will be some funding available too for doing particular pilots and work. And all of that's going to launch in the next 3 weeks or so. So if you're doing work now that you think is related to ethical use of geospatial data or would have a relationship to that, please come and have a chat with me, or come and have a chat with us at Geovation in the next little while, and look out for when the announcement comes for this, because this is a program of work that's going to go now for about 6 to 12 months. And what we're really looking to do is develop tangible tools. So this is not just an academic exercise. This is about developing tangible tools that you'll be able to use, that organisations will be able to use, to be able to prove and show and build trust with people in how they're ethically using the data. So the second trend I wanted to talk about was diversity. Now I know this is a very loaded term at times. So you'll see some other words that I put up here in saying that diversity is about a range of different things. A variety, miscellany, assortment, a mix. Yes, gender is one of those things we talk about with diversity, but it isn't the only part of diversity. And I think that's a really important part of this particular trend, is understanding how we bring diversity into what we're doing so we make better decisions. That said, I am going to bring the gender one up here because, as I said, I've worked in this industry now for 20 years. I can tell you all sorts of wonderful stories about being the only female in a room of 200 guys when I walk into conferences. But I was really horrified to see this piece of research coming out of New Zealand, which, frankly, I come from Australia. Australia and New Zealand are actually, I think, usually pretty good in terms of their balancing on the gender scale here. But to find that 62% of young women still don't see themselves as staying in the GIS industry, and part of that is because they're not seeing females in the senior leadership roles, really scared me that we're still at this sort of space. But there is hope. And the hope comes in the form of geospatial women and movements like this that are happening around the world. You will also have heard, hopefully, of GeoChickers that's going on, and I know Esri and Dawn Wright have been doing a lot of work for a really long period of time. Geospatial Women is literally just a bunch of people like you that thought, ooh, we should get something together and make something happen. I'm looking over here at Olive over here as well. I've met some fantastic women in this space that have shared incredibly positive stories and incredibly positive ideas for how we can improve things. The network is certainly not something that is about gender bashing. It's not about guy bashing in this situation. And in fact, there's a lot of really supportive people from all walks of life that participate in this. So with that, I want to highlight this particular program. So this was launched a few weeks ago, and we're looking for people to apply in it at the moment. So it's a mentorship program. It is specifically about looking at mentoring women, but we are looking for mentors from everywhere. So we want to make sure that the mentors and peers that support this are actually looking at diversity from all angles. And so while the network at the moment is focused somewhat on building the, bridging the gender balance, what we're rapidly finding is actually that the dialogue is moving much broader than that. The dialogue's moving into diversity conversations around age. It's moving into diversity conversations even I've had about politics and how we need to be better and more open at different political views in our work. And really it's starting to move into a space at the moment about how do we build a culture that means that we're really open to somebody else's point of view and that it might be different to ours and be willing to accept that. The reason why that's valuable is you build better solutions when you've got that sort of diversity in what you're doing. You know, I was horrified last year, someone sent me a meme little video thing, and it was of a, I don't know how many people have seen this one, but it's of an automatic hand sanitizer that's in a bathroom. And if you put my hand under it, it would give you soap. If I put a white piece of paper under it, it would give you soap. And if you put a brown hand underneath it, you would get nothing. Now, no one intentionally made this a racist soap dispenser. But what it showed was that in the testing phase of that, there wasn't the diversity of people there to think, well, we should do that, and we should change the way, and we should test these different things that are there. So it's really important to look at how we build that diversity in what we do. And if anyone is at all interested in this, please do have a look at becoming a part of the program. If you're interested in being a mentee, if you're interested in being a mentor, if you simply want to be a supporter of what's going on in this network, please do come and find us. I know that Olivia has put a bunch of the cards out on the tables upstairs, and we've got some other cards that can give you the contact details there as well. That would be the cards. So why am I telling you about all of this? The reality is, I think, that there is a real opportunity for this industry to be an agent of change in everything that's going on in the world. You would all see the media this week of the climate strikes that are coming on Friday. I think it's without doubt now that we've got some major, major issues that are going on the planet that require some really careful thinking about how we contribute to them and the difference that we can make in that space. And so I thought I'd finish a little bit with a bit of a video. So Samaritan is an organisation that I came across earlier this year while I was in Seattle at a thing called Retail Loco. So big marketing organisations, retail sector, etc., and up pops this little gem of a project that's happened. And this was the brainchild of one person who was walking through the streets of Seattle and noticed the homeless population problem that they had and thought there has to be a better way to do this. I'm sure I can come up with a tech way of sorting this out. And so this is a gorgeous one that shows the power of what location can actually do. So I can tell you with that particular project, that's completely altered the homeless situation in Seattle in the way that works. There have been stories of companies that have found someone through the background that they read on there and have given them a job out of it. There are stories in there of businesses that have changed their practices to be able to include people that need work and put them into and give them new skills in what they're doing. So the incredible nature of that is that simple act of having a bit of location tech on someone has suddenly made them real. They've made them a person, they've made them an individual and a personality for you to know about. And it becomes much harder to walk past a problem like that when they actually have a story to them and they have a background that you can understand. But it's an incredible example, I think, of the power of how one person's great idea can change, using location data, can change people's lives and significant number of people's lives throughout the world. So for me, working in this industry, as William Priest used to say last year all the time, we're really in a geospatial moment. There is such incredible opportunity for us to do amazing good at the moment. But I guess, as in the words of Spider-Man, with great power comes great responsibility. And I think that it behoves all of us to think about that responsibility as role models in the industry, in how we operate, in how we build systems, in how we work together. And we can only really achieve all of these amazing things, actually, if we do work together. So we have to find those better and ethical ways to operate. We have to find more open methods by which to take in new ideas and which to be open to that diverse notion of what we can do. So what can you do? Let me leave you with a couple of thoughts then. When you go back into your work, consider the ethics of what you're doing. Consider whether everything you are doing is as good as it could be. Be more conscious of things like unconscious bias. So by that I mean thinking about, am I naturally ignoring other people's ideas because of their background? And I don't even mean to be doing that. Am I not taking into consideration someone's opinion because they're too young, because I think they're too young or I think they're too old in this situation? Think consciously about how you're interacting with each of your people, and think of how your business and your organisation runs as well, and if you've got a power of influence to improve that somehow. I saw a great application this week, I think it's called Text.io, which is a service that allows you to take job descriptions and run it through a system that will actually tell you how gender biased the wording is that you've used in there, and how biased it is to particular areas as well. So it then offers you suggestions as to how you might improve that. And as a result, you might get better staff. So be more open to different ideas and perspectives. Be bold in what you do, be courageous in what you do, and be a change. And this is my last shameless plug, and I did double check with Tom that I was allowed to do this one. If you are really interested in being part of that agent of change, I'd really encourage you to come to this year's GeoCom. I do sit on the AGI board, and one of the things that we talked a lot about in terms of theme this year was picking a theme that really is something that can actually be an agent of change. So we're talking about climate, we're talking about the net zero targets across the course of this day, and we're really looking for people to be part of that dialogue and see how we can bring the geospatial industry into the fore of being the supporter of making that happen. So be the change, and thank you for listening. Happy to take any questions.
Any questions for this?
Thinking about the ethics of your example here, the thing that strikes me is, and it may have been successful in Seattle, but it's a recommendation of time series geotagging the homeless population of a city. And is that while that may be useful in a somewhat beneficent sense in certain circumstances, you turn that around in a situation where the powers that be, whomever, have no love for that community. And this could be applied to any number of marginalized communities. can be incredibly dangerous.
Absolutely.
So is that, and it's wonderful to see when certain tech solutions work out to the benefit, but I get really, really nervous when I start hearing folks from certain corners of the Western United States start throwing up apps to solve the world's broad poverty issues.
No, I take that on board completely and utterly, and it was really interesting talking to the founders of that and their concerns, I guess, about the protection of those people's information. So the tag is to them as a person, as opposed to, I guess, them as to where they stay or where they sleep. So there's a lot of that concern that they took into account there in terms of the security of how that data is actually managed. But I couldn't agree with you more, which I think is why the ethics debate is so important when we start doing this. I thought I saw another hand pop up. No? Yeah.
Actually a geolocation.
Yeah.
Not actually like search for it. It's not like they haven't got a database of like where they all
Yeah.
are. It's just literally a tag.
It's a little beacon tag. Curiosity, with the potential geovation work that we're looking at doing, how many people in this room are likely to be looking out for that one when it comes out? Good to see, good to see. I'd love to see some more hands up. The reason I say that is that the discussions that we're going to be having will really be covering a broad section, and I think we are going to need the broadest sense of people coming and participating in them. So I do implore that you get involved with that as it appears, if you possibly can. We are going to try and make sure they certainly cover the country nicely, so it won't just all be stuck in London. No other questions? I'm really conscious that I'm now between you guys and beer, and that's never a good position to be in at the end of the day. Brilliant. Thanks very much, everybody. Have a good conference.
Brilliant. Thank you, Denise. That was fantastic. There's a lot to take away there. Hopefully that will challenge people to get involved and think about the work that they do. As Denise said, there is a party happening at the Counting House, which somewhere over there. We're all geographers. We'll find our way there. It's at 6 o'clock. Just a little bit of admin for tomorrow. If you guys could please just wear your tags tomorrow so that we can count you in, that'd be great. As we said earlier, Nick has got tickets available on the community sprint on Saturday to help look at QGIS documentation. Tom Chadwin is hoping to be involved, maybe remotely, but to look at his QGIS to web plugin. And there's also possibly an opportunity to look at fixing some bugs in GeoNode, if there's anybody brave enough to dive into a bit of Java and something else. But that's it for now. Just on behalf of all the volunteers and the organizing committee, just a massive thank you for being such a great crowd today. It's been super easy to work with you all. We will see you in the Counting House from 6 o'clock. Thank you very much.